Section 26 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Joanne Crosby. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 26. Part 3. Chemical Colors. 486. We give this denomination to colors which we can produce and more or less fix in certain bodies, which we can render more intense, which we can again take away and communicate to other bodies, and to which, therefore, we ascribe a certain permanency. Duration is their prevailing characteristic. 487. In this view, the chemical colors were formerly distinguished with various epithets. They were called color proprii, corpori, materiale, vari, permanente, fixi. 488. In the preceding chapter, we observed how the fluctuating and transient nature of the physical colors becomes gradually fixed, thus forming the natural transition to our present subject. 489. Color becomes fixed in bodies more or less permanently, superficially, or thoroughly. 490. All bodies are susceptible of color. It can either be excited, rendered intense, and gradually fixed in them, or at least communicated to them. 34. Chemical contrast. 491. In the examination of colored appearances, we had occasion everywhere to take notice of a principle of contrast. So again, in approaching the precincts of chemistry, we find a chemical contrast of a remarkable nature. We speak here, with reference to our present purpose, only of that which is comprehended under the general names of acid and alkali. 492. We characterize the chromatic contrast in conformity with all other physical contrasts as a more or less, subscribing the plus to the yellow side, the minus to the blue, and we now find that these two divisions correspond with the chemical contrasts. The yellow and the yellow-red affect the acids, the blue and the blue-red, the alkali. Thus the phenomena of chemical colors, although still necessarily mixed up with other considerations, admit of being traced with sufficient simplicity. 493. The principal phenomena in chemical colors are produced by the oxidation of metals, and it will be seen how important this consideration is at the onset. Other facts which come into the account, and which are worthy of attention, will be examined under separate heads. In doing this, we, however, expressly state that we only propose to offer some preparatory suggestions to the chemist in a very general way, without entering into the nicer chemical problems and questions or presuming to decide on them. Our object is only to give a sketch of the mode in which, according to our convictions, the chemical theory of colors may be connected with general physics. End of section 26. Section 27 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Joanne Crosby. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 27. 35. White. 494. In treating of the diotropic colors of the first class, we have already in some degree anticipated this subject. Transparent substances may be said to be in the highest class of inorganic matter. With these, colorless semi-transparence is closely connected, and white may be considered the last opaque degree of this. 495. Pure water crystallized to snow appears white, for the transparence of the separate parts makes no transparent whole. Various crystallized salts, when deprived to a certain extent of moisture, appear as white powder. The accidentally opaque state of a pure transparent substance might be called white. Thus pounded glass appears as a white powder. The cessation of a combining power and the exhibition of the atomic quality of the substance might at the same time be taken into account. 496. The known undecomposed earths are in their pure state all white. They pass to a state of transparence by natural crystallization. Silex becomes rock crystal, argile, mica, magnesia, talc, calcareous earth, and barite appear transparent in various spars. 497. As in the coloring of mineral bodies, the metallic oxides will often invite our attention. We observe, in conclusion, that metals, when slightly oxidated, at first appear white, as lead is converted to white lead by vegetable acid. 36. Black. 498. Black is not exhibited in so elementary a state as white. We met with it in the vegetable kingdom in semi-combustion, and charcoal, a substance especially worthy of attention on other accounts, exhibits a black color. Again, if woods, for example boards, owing to the action of light, air, and moisture, are deprived in part of their combustibility, there appears first the gray, then the black color. So again we can convert even portions of animal substance to charcoal by semi-combustion. 499. In the same manner, we often find that a suboxidation takes place in metals when the black color is to be produced. Various metals, particularly iron, become black by slight oxidation, by vinegar, by mild acid fermentations, for example, a decoction of rice and C. 500. Again, it may be inferred that deoxidation may produce black. This occurs in the preparation of ink, which becomes yellow by the solution of iron in strong sulfuric acid, but when partly deoxidized by the infusion of gallnuts, appears black. 37. First excitation of color. 501. In the division of physical colors, where semi-transparent mediums were considered, we saw colors antecedently to white and black. In the present case, we assume a white and black already produced and fixed, and the question is, how color may be excited in them. 502. Here, too, we can say, white that becomes darkened or dimmed inclines to yellow. Black, as it becomes lighter, inclines to blue. 503. Yellow appears on the active plus side, immediately in the light, the bright, the white. All white surfaces easily assume a yellow tinge. Paper, linen, wool, silk, wax, transparent fluids again, which have a tendency to combustion, easily become yellow. In other words, they easily pass into a very slight state of semi-transparence. 504. So again, the excitement on the passive side, the tendency to obscure, dark black, is immediately accompanied with blue, or rather with a reddish blue. Iron dissolved in sulfuric acid and much diluted with water, if held to the light in a glass, exhibits a beautiful violet color as soon as a few drops only of the infusion of gallnuts are added. This color presents the peculiar hues of the dark topaz, the orphinion of a burnt red, as the ancients expressed it. 505. Whether any color can be excited in the pure earths by the chemical operations of nature and art, without the admixture of metal oxides, is an important question generally, indeed answered in the negative. It is perhaps connected with the question, to what extent changes may be produced in the earths through oxidation. 506. Undoubtedly, the negation of the above question is confirmed by the circumstances that whenever mineral colors are found, some trace of metal, especially of iron, shows itself. We are thus naturally led to consider how easily iron becomes oxidized, how easily the oxidate of iron assumes different colors, how infinitely divisible it is, and how quickly it communicates its color. It were to be wished, notwithstanding, that new experiments could be made in regard to the above point, so as to either confirm or remove any doubt. 507. However this may be, the susceptibility of the earth with regard to colors already existing is very great. A luminous earth is thus particularly distinguished. 508. In proceeding to consider the metals, which in the inorganic world have the almost exclusive prerogative of appearing colored, we find that, in their pure independent natural state, they are already distinguished from the pure earths by a tendency to some one color or other. 509. While silver approximates most to pure white, nay, really represents pure white, heightened by metallic splendor. Steel, tin, lead, and so forth incline towards pale blue-gray. Gold, on the other hand, deepens to pure yellow. Copper approaches a red hue, which, under certain circumstances, increases almost to bright red, but which again returns to a yellow-golden color when combined with zinc. 510. But if metals in their pure state have so specific a determination towards this or that exhibition of color, they are, through the effect of oxidation, in some degree reduced to a common character. For the elementary colors now come forth in their purity, and although this or that metal appears to have a particular tendency to this or that color, we find some that can go through the whole circle of hues, others that are capable of exhibiting more than one color. Tin, however, is distinguished by its comparative inaptitude to becoming colored. We propose to give a table hereafter, showing how far the different metals can be more or less made to exhibit the different colors. 511. When the clean, smooth surface of a pure metal, on being heated, becomes overspread with a mantling color, which passes through a series of appearances as the heat increases, this, we are persuaded, indicates the aptitude of the metal to pass through the whole range of colors. We find this phenomenon most beautifully exhibited in polished steel, but silver, copper, brass, lead, and tin easily present similar appearances. A superficial oxidation is probably here taking place, as may be inferred from the effects of the operation when continued, especially in the more easily oxidizable metals. 512. The same conclusion may be drawn from the fact that iron is more easily oxidizable by acid liquids when it's red hot, for in this case the two effects concur with each other. We observe again that steel, accordingly as it is hardened in different stages of its colorification, may exhibit a difference of elasticity. This is quite natural, for the various appearances of color indicates various degrees of heat. 513. If we look beyond this superficial mantling, this pellicle of color, we observe that as metals are oxidized throughout their masses, white or black appears with the first degree of heat, as may be seen in white lead, iron, and quicksilver. 514. If we examine further and look for the actual exhibition of color, we find it most frequently on the plus side. The mantling so often mentioned of smooth metallic surfaces begins with yellow. Iron passes presently into yellow ochre, lead from white lead to maziacat, quicksilver from Ethiops to yellow turbith. The solutions of gold and platinum in acids are yellow. 515. The exhibition on the minus side are less frequent. Copper slightly oxidized appears blue. In the preparation of Prussian blue, alkalis are employed. 516. Generally, however, these appearances of color are of so mutable a nature that chemists look upon them as deceptive tests, at least in the nicer gradations. For ourselves, as we can only treat of these matters in a general way, we merely observe that the appearances of color in metals may be classed according to their origin, manifold appearances, and cessation as various results of oxidation, hyperoxidation, aboxidation, and deoxidation. End of section 27.
Section 28 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 28. 38. Augmentation of color. 517. The augmentation of color exhibits itself as a condensation, a fullness, a darkening of the hue. We have before seen, in treating of colorless mediums, that by increasing the degree of opacity in the medium, we can deepen a bright object from the lightest yellow to the intensest ruby red. Blue, on the other hand, increases to the most beautiful violet if we rarefy and diminish a semi-opaque medium, itself lighted, but through which we see darkness. 150, 151. 518. If the color is positive, A similar color appears in the intenser state. Thus, if we fill a white porcelain cup with a pure yellow liquor, the fluid will appear to become gradually redder toward the bottom, and at last appears orange. If we pour a pure blue solution into another cup, the upper portion will exhibit a sky blue, that towards the bottom a beautiful violet. If the cup is placed in the sun, the shadowed side, even of the upper portion, is already violet. If we throw a shadow with the hand, or any other substance, over the illuminated portion, the shadow, in like manner, appears reddish. 519. This is one of the most important appearances connected with the doctrine of colors, for we here manifestly find that a difference of quantity produces a corresponding qualified impression on our senses. In speaking of the last class of epoptical colors, 452, 485, we stated our conjecture that the coloring of steel might perhaps be traced to the doctrine of the semi-transparent mediums, and we would here again recall this to the reader's recollection. 520. All chemical augmentation of color, again, is the immediate consequence of continued excitation. The augmentation advances constantly and unremittingly, and it is to be observed that the increase of intenseness is most common on the plus side. Yellow iron ochre increases, as well by fire as by other operations, to a very strong red. Massicot is increased to red lead, turbith to vermilion, which last obtains a very high degree of the yellow red. An intimate saturation of the metal by the acid, and its separation to infinity, take place together with the above effects. 521. The augmentation on the minus side is less frequent, but we observe that the more pure and condensed the Prussian blue or cobalt glass is prepared, the more readily it assumes a reddish hue and inclines to the violet. 522. The French have a happy expression for the less perceptible tendency of yellow and blue towards red. They say the color has un île de rouge, which we might perhaps express by a reddish glance, einen rötlichen Blick. 39. Culmination. 523. This is the consequence of still progressing augmentation. Red, in which neither yellow nor blue is to be detected, here constitutes the acme. 524. If we wish to select a striking example of a culmination on the plus side, we again find it in the colored steel, which attains the bright red acme, and can be arrested at this point. 525. Were we here to employ the terminology before proposed, we should say that the first oxidation produces yellow, the hyperoxidation yellow-red, that here a kind of maximum exists, and that then an ab-oxidation, and lastly a de-oxidation takes place. 526. High degrees of oxidation produce a bright red. Gold in solution, precipitated by a solution of tin, appears bright red. Oxide of arsenic, in combination with sulphur, produces a ruby color. 527. How far, however, a kind of sub-oxidation may cooperate in some culminations is matter for inquiry, for an influence of alkalis on yellow-red also appears to produce the culmination, the color reaching the acme by being forced towards the minus side. 528. The Dutch prepare a color known by the name of vermilion, from the best Hungarian cinnabar, which exhibits the brightest yellow-red. This vermilion is still only a cinnabar, which, however, approximates the pure red, and it may be conjectured that alkalis are used to bring it nearer to the culminating point. 529. Vegetable juices, treated in this way, offer very striking examples of the above effects. The coloring matter of turmeric, annatto, dyer's saffron, and other vegetables, being extracted with spirits of wine, exhibit tints of yellow, yellow-red, and hyacinth red. These, by the admixture of alkalis, pass to the culminating point, and even beyond it to blue-red. 530. No instance of a culmination on the minus side has come to my knowledge in the mineral and vegetable kingdoms. In the animal kingdom, the juice of the murex is remarkable. Of its augmentation and culmination on the minus side, we shall hereafter have occasion to speak. 40. Fluxation. 531. The mutability of colors is so great that even those pigments, which may have been considered to be defined and arrested, still admit of slight variations on one side or the other. This mutability is most remarkable near the culminating point, and is effected in a very striking manner by the alternate employment of acids and alkalis. 532. To express this appearance in dyeing, the French make use of the word virer, to turn from one side to the other. They thus very adroitly convey an idea which others attempt to express by terms indicating the component hues. 533. The effect produced with litmus is one of the most known and striking of this kind. This coloring substance is tendered red-blue by means of alkalis. The red-blue is very readily changed to red-yellow by means of acid, and again returns to its first state by again employing alkalis. The question whether a culminating point is to be discovered and arrested by nice experiments is left to those who are practised in these operations. Dyeing, especially scarlet dyeing, might afford a variety of examples of this fluctuation. 41. Passage through the whole scale. 534. The first excitation and gradual increase of color take place more on the plus than on the minus side. So, also, in passing through the whole scale, color exhibits itself most on the plus side. 535. A passage of this kind, regular and evident to the senses, from yellow through red to blue, is apparent in the coloring of steel. 536. The metals may be arrested at various points of the colorific circle by various degrees and kinds of oxidation. 537. As they also appear green, a question arises whether chemists know any instance in the mineral kingdom of a constant transition from yellow through green to blue, and vice versa. Oxide of iron melted with glass produces first a green, and with a more powerful heat a blue color. 538. We may here observe of green generally that it appears, especially in an atomic sense, and certainly in a pure sense, when we mix blue and yellow. But again an impure and dirty yellow soon gives us the impression of green. Yellow and black already produce green. This, however, is owing to the affinity between black and blue. An imperfect yellow, such as that of sulphur, gives us the impression of a greenish hue. Thus, again, an imperfect blue appears green. The green of wine bottles arises, it appears, from an imperfect union of the oxide of iron with the glass. If we produce a more complete union by greater heat, a beautiful blue glass is the result. 539. From all this it appears that a certain chasm exists in nature between yellow and blue, the opposite character of which, it is true, may be done away atomically by due immixture, and thus combined to green. But the true reconciliation between yellow and blue, it appears, only takes place by means of red. 540. The process, however, which appears unattainable in inorganic substances, we shall find to be possible when we turn our attention to organic productions, for in these the passage through the whole circle from yellow through green and blue to red really takes place. End of section 28. Recording by Todd. Section 29 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 29. 42. Inversion. 541. Again, an immediate inversion, or change to the totally opposite hue, is a very remarkable appearance which sometimes occurs. At present we are merely enabled to adduce what follows. 452. The mineral chameleon, a name which has been given to an oxide of manganese, may be considered, in its perfectly dry state, as a green powder. If we strew it in water, the green color displays itself very beautifully in the first moment of solution, but it changes presently to the bright red opposite to green, without any apparent intermediate state. 543. The same occurs with the sympathetic ink, which may be considered a reddish liquid, but which, when dried by warmth, appears as a green color on paper. 544. In fact, this phenomena appears to be owing to the conflict between a dry and moist state, as has already been observed, if we are not mistaken, by the chemists. We may look to the improvements of time to point out what may further be deduced from these phenomena, and to show what other facts they may be connected with. 43. Fixation. 545. Mutable as we have hitherto found color to be, even as a substance, yet under certain circumstances it may at last be fixed. 546. There are bodies capable of being entirely converted into coloring matter. Here it may be said that the color fixes itself in its own substance, stops at a certain point, and is there defined. Such coloring substances are found throughout nature. The vegetable world affords a great quantity of examples, among which some are particularly distinguished, and may be considered as the representatives of the rest, such as, on the active side, matter; on the passive side, indigo. 547. In order to make these materials available in use, it is necessary that the coloring quality in them should be intimately condensed, and the tinging substance refined, practically speaking, to an infinite divisibility. This is accomplished in various ways, and particularly by the well-known means of fermentation and decomposition. 548. These coloring substances now attach themselves again to other bodies. Thus, in the mineral kingdom, they adhere to earths and metallic oxides. They unite in melting with the glasses, and in this case, as the light is transmitted through them, they appear in the greatest beauty, while an eternal duration may be ascribed to them. 549. They fasten on vegetable and animal bodies with more or less power, and retain more or less permanently, partly owing to their nature, as yellow, for example, is more effervescent than blue, or owing to the nature of the substance on which they appear. They last less in vegetable than in animal substances, and even within this latter kingdom there are again varieties. Hemp or cotton threads, silk or wool, exhibit very different relations to coloring substances. 550. Here comes into the account the important operation of employing mordants, which may be considered as the intermediate agents between the color and the recipient substance. Various works on dyeing speak of this circumstantially. Suffice it to have been alluded to processes by means of which the color retains a permanency only to be destroyed with the substance, and which may even increase in brightness and beauty by use. 44. Intermixture, real. 551. Every intermixture presupposes a specific state of color, and thus when we speak of intermixture, we here understand it in an atomic sense. We must first have before us certain bodies arrested at any given point of the colorific circle, before we can produce gradations by their union. 552. Yellow, blue, and red may be assumed as pure elementary colors, already existing. From these, violet, orange, and green are the simplest combined results. 553. Some persons have taken much pains to define these intermixtures more accurately, by relations of number, measure, and weight, but nothing very profitable has been thus accomplished. 554. Painting consists, strictly speaking, in the intermixture of such specific coloring bodies and their infinite possible combinations, combinations which can only be appreciated by the nicest, most practised eye, and only accomplished under its influence. 555. The intimate combination of these ingredients is effected, in the first instance, through the most perfect comminution of the material by means of grinding, washing, etc., as well as by vehicles or liquid mediums which hold together the pulverized substance, and combined organically, as it were, the inorganic. Such are the oils, resins, etc. 556. If all the colors are mixed together, they retain their general character as scaron, and as they are no longer seen next to each other, no completeness, no harmony is experienced. The result is gray, which, like apparent color, always appears somewhat darker than white, and somewhat lighter than black. 557. This gray may be produced in various ways: by mixing yellow and blue to an emerald green, and then adding pure red, till all three neutralize each other; or by placing the primitive and intermediate colors next each other in certain proportion, and afterwards mixing them. 558. That all the colors mixed together produce white is an absurdity which people have credulously been accustomed to repeat for a century, in opposition to the evidence of their senses. 559. Colors, when mixed together, retain their original darkness. The darker the colors, the darker will be the gray resulting from their union, till at last this gray approaches black. The lighter the colors, the lighter will be the gray, which at last approaches white. 45. Intermixture, apparent. 560. The intermixture, which is only apparent, naturally invites our attention in connection with the foregoing. It is in many respects important, and indeed the intermixture which we have distinguished as real might be considered as merely apparent, for the elements of which the combined color consists are only too small to be considered as distinct parts. Yellow and blue powders mingled together appear green to the naked eye, but through a magnifying glass we can still perceive yellow and blue distinct from each other. Thus yellow and blue stripes seen at a distance present a green mass. The same observation is applicable with regard to the intermixture of other specific colors. 561. In the description of our apparatus we shall have occasion to mention the wheel, by means of which the apparent intermixture is produced by rapid movement. Various colors are arranged near each other round the edge of a disc, which is made to revolve with velocity, and thus by having several such discs ready, every possible intermixture can be presented to the eye, as well as the mixture of all colors to gray, darker or lighter according to the depth of the tints as above explained. 562. Physiological colors admit, in like manner, of being mixed with others. If, for example, we produce the blue shadow 65 on a light yellow paper, the surface will appear green. The same happens with regard to the other colors if the necessary preparations are attended to. 563. If, when the eye is impressed with visionary images that last for a while, we look on colored surfaces, an intermixture also takes place. The spectrum is determined to a new color which is composed of the two. 564. Physical colors also admit of combination. Here might be adduced the experiments in which many colored images are seen through the prism, as we have before shown in detail. 258, 284. 565. Those who have prosecuted these inquiries have, however, paid most attention to the appearances which take place when the prismatic colors are thrown on colored surfaces. 566. What is seen under these circumstances is quite simple. In the first place, it must be remembered that the prismatic colors are much more vivid than the colors of the surfaces on which they are thrown. Second, we have to consider that the prismatic colors may be either homogeneous or heterogeneous with the recipient surface. In the former case, the surface deepens and enhances them, and it is itself enhanced in return as a colored stone is displayed by a similarly colored foil. In the opposite case, each vitiates, disturbs, and destroys the other. 567. These experiments may be repeated with colored glasses, by causing the sunlight to shine through them on colored surfaces. In every instance, similar results will appear. 568. The same effect takes place when we look on colored objects through colored glasses, the colors being thus according to the same conditions enhanced, subdued, or neutralized. 569. If the prismatic colors are suffered to pass through colored glasses, the appearances that take place are perfectly analogous. In these cases more or less force, more or less light and dark, the clearness and cleanness of the glass are all to be allowed for they produce many delicate varieties of effect. These will not escape the notice of every accurate observer who takes sufficient interest in the inquiry to go through the experiments. 570. It is scarcely necessary to mention that several colored glasses, as well as oiled or transparent papers, placed over each other, may be made to produce and exhibit every kind of intermixture at pleasure. 571. Lastly, the operation of glazing in painting belongs to this kind of intermixture. By this means a much more refined union may be produced than that arising from the mechanical atomic mixture which is commonly employed. End of Section 29. Recording by Todd. Section 30 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 30. 46. Communication, actual. 572. Having now provided the coloring materials, as before shown, a further question arises how to communicate these to colorless substances. The answer is of the greatest importance from the connection of the object with the ordinary wants of men, with useful purposes, and with commercial and technical interests. 573. Here, again, the dark quality of every color again comes into the account. From a yellow that is very near to white, through orange, and the hue of minimum, to pure red and carmine, through all gradations of violet to the deepest blue which is almost identified with black, color still increases in darkness. Blue, once defined, admits of being diluted, made light, united with yellow, and then, as green, it approaches the light side of the scale, but this is by no means according to its own nature. 574. In the physiological colors, we have already seen that they are less than the light, inasmuch as they are a repetition of an impression of light, nay, at last they leave this impression quite as a dark. In physical experiments, the employment of semi-transparent mediums, the effect of semi-transparent accessory images, taught us that in such cases we have to do with a subdued light, with a transition to darkness. 575. In treating of the chemical origin of pigments, we found that the same effect was produced on the very first excitement. The yellow tinge which mantles over the steel already darkens the shining surface. In changing white lead to massicot, it is evident that the yellow is darker than the white. 576. This process is in the highest degree delicate. The growing intenseness, as it still increases, tinges the substance more and more intimately and powerfully, and thus indicates the extreme fineness and the infinite divisibility of the colored atoms. 577. The colors which approach the dark side, and consequently blue in particular, can be made to approximate to black. In fact, a very perfect Prussian blue or an indigo, acted on by vitriolic acid, appears almost as a black. 578. A remarkable appearance may here be adverted to. Pigments, in their deepest and most condensed state, especially those produced from the vegetable kingdom, such as the indigo just mentioned, or madder carried to its intensest hue, no longer show their own color. On the contrary, a decided metallic shine is seen on their surface, in which the physiological compensatory color appears. 579. All good indigo exhibits a copper color in its fracture, a circumstance attended to, as a known characteristic, in trade. Again, the indigo which has been acted on by sulphuric acid, if thickly laid on, or suffered to dry so that neither white paper nor the porcelain can appear through, exhibits a color approaching to orange. 580. The bright red Spanish rouge, probably prepared from madder, exhibits on its surface a perfectly green metallic shine. If this color, or the blue before mentioned, is washed with a pencil on porcelain or paper, it is seen in its real state, owing to the bright ground shining through. 581. Colored liquids appear black when no light is transmitted through them, as we may easily see in cubic tin vessels with glass bottoms. In these, every transparent colored infusion will appear black and colorless if we place a black surface under them. 582. If we contrive that the image of a flame be reflected from the bottom, the image will appear colored. If we lift up the vessel, and suffer the transmitted light to fall on white paper under it, the color of the liquid appears on the paper. Every light ground seen through such a colored medium exhibits the color of the medium. 583. Thus every color, in order to be seen, must have a light within or behind it. Hence the lighter and brighter the grounds are, the more brilliant the colors appear. If we pass lac varnish over a shining white metal surface, as the so-called foils are prepared, the splendor of the color is displayed by this internally reflected light as powerfully as in any prismatic experiment. Nay, the force of the physical colors is owing principally to the circumstance that light is always acting within and behind them. 584. Lichtenberg, who of necessity followed the received theory, owing to the time and circumstances in which he lived, was yet too good an observer and too acute not to explain and classify, after his fashion, what was evident to his senses. He says, in the preface to De Laval, "It appears to me also, on other grounds, probable, that our organ, in order to be impressed by a color, must at the same time be impressed by all light, white." 585. To procure white as a ground is the chief business of the dyer. Every color may be easily communicated to colorless earths, especially to alum, but the dyer has especially to do with animal and vegetable products as the ground of his operations. 586. Everything living tends to color, to local, specific color, to effect, to opacity, pervading the minutest atoms. Everything in which life is extinct approximates to white. 494. To the abstract, the general state, to cleanness, to transparence. 587. How this is put in practice in technical operations remains to be adverted to in the chapter on the privation of color. With regard to the communication of color, we have especially to bear in mind that animals and vegetables, in a living state, produce colors, and hence their substances, if deprived of colors, can the more readily reassume them. 47. Communication apparent. 588. The communication of colors, real as well as apparent, corresponds, as may easily be seen, with their intermixture. We need not, therefore, repeat what has already been sufficiently entered into. 589. Yet we may here point out more circumstantially the importance of an apparent communication which takes place by means of reflection. This phenomena is well known, but still it is pregnant with inferences, and is of the greatest importance both to the investigator of nature and to the painter. 590. Let a surface colored with any one of the positive colors be placed in the sun, and let its reflection be thrown on other colorless objects. This reflection is a kind of subdued light, a half-light, a half-shadow, which, in a subdued state, reflects the colors in question. 591. If this reflection acts on light surfaces, it is so far overpowered that we can scarcely perceive the color which accompanies it. But if it acts on shadowed portions, a sort of magical union takes place with the sciera. Shadow is the proper element of color, and in this case a subdued color approaches it, lighting up, tinging, and enlivening it, and thus arises an appearance, as powerful as agreeable, which may render the most pleasing service to the painter who knows how to make use of it. These are the types of the so-called reflexes, which were only noticed late in the history of art, and which have been too seldom employed in their full variety. 592. The schoolmen call these colors colores notionales and intentionales, and the history of the doctrine of colors will generally show that the old inquirers already observed the phenomena well enough, and knew how to distinguish them properly, although the whole method of treating such subjects is very different from ours. End of Section 30. Recording by Todd.
Section 31 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Recording by Susie. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Sections 48 and 49. Section 48. Extraction. 593. Color may be extracted from substances, whether they possess it naturally or by communication, in various ways. We have thus the power to remove it intentionally for a useful purpose, but, on the other hand, it often flies contrary to our wish. 594. Not only are the elementary earths in their natural state white, but vegetable and animal substances can be reduced to a white state without disturbing their texture. A pure white is very desirable for various uses, as in the instance of our preferring to use linen and cotton stuffs uncolored. In like manner, some silk stuffs, paper, and other substances are the more agreeable the whiter they can be. Again, the chief basis of all dyeing consists in white grounds. For these reasons, manufacturers, aided by accident and contrivance, have devoted themselves assiduously to discover means of extracting color. Infinite experiments have been made in connection with this object, and many important facts have been arrived at. 595. It is in accomplishing this entire extraction of color that the operation of bleaching consists, which is very generally practiced empirically or methodically. We will here shortly state the leading principles. 596. Light is considered as one of the first means of extracting color from substances, and not only the sunlight, but the mere powerless daylight. For as both lights, the direct light of the sun, as well as the derived light of the sky, kindle Bologna phosphorus, so both act on colored surfaces. Whether the light attacks the color allied to it, and, as it were, kindles and consumes it, thus reducing the definite quality to a general state, or whether some other operation unknown to us takes place, it is clear that light exercises a great power on colored surfaces, and bleaches them more or less. Here, however, the different colors exhibit a different degree of durability. Yellow, especially if prepared from certain materials, is, in this case, the first to fly. 597. Not only light, but air, and especially water, act strongly in destroying color. It has been even asserted that thread, well soaked and spread on the grass at night, bleaches better than that which is exposed, after soaking, to the sunlight. Thus, in this case, water proves to be a solving and conducting agent, removing the accidental quality, and restoring the substance to a general or colorless state. 598. The extraction of color is also affected by reagents. Spirits of wine has a peculiar tendency to attract the juice which tinges plants, and becomes colored with it often in a very permanent manner. Sulfuric acid is very efficient in removing color, especially from wool and silk, and everyone is acquainted with the use of sulfur vapors in bleaching. 599. The strongest acids have been recommended more recently as more expeditious agents in bleaching. 600. The alkaline reagents produce the same effects by contrary means. Lixiviums alone, oils and fat combined with lixiviums to soap, and so forth. 601. Before we dismiss this subject, we observe that it may be well worth while to make certain delicate experiments as to how far light and air exhibit their action in the removal of color. It might be possible to expose colored substances to the light under glass bells, without air or filled with common or particular kinds of air. The colors might be those of known fugacity, and it might be observed whether any of the volatilized color attached itself to the glass or was otherwise perceptible as a deposit or precipitate. Whether, again, in such a case, this appearance would be perfectly like that which had gradually ceased to be visible, or whether it had suffered any change. Skillful experimentalists might devise various contrivances with a view to such researches. 602. Having thus first considered the operations of nature as subservient to our proposes, we add a few observations on the modes in which they act against us. 603. The art of painting is so circumstanced that the most beautiful results of mind and labor are altered and destroyed in various ways by time. Hence, great pains have been always taken to find durable pigments, and so to unite them with each other and with their ground, that their permanency might be further ensured. The technical history of the schools of painting affords sufficient information on this point. 604. We may here too mention a minor art to which, in relation to dyeing, we are much indebted, namely the weaving of tapestry. As the manufacturers were enabled to imitate the most delicate shades of pictures, and hence often brought the most variously colored materials together, it was soon observed that the colors were not all equally durable, but that some faded from the tapestry more quickly than others. Hence, the most diligent efforts were made to ensure an equal permanency to all the colors and their gradations. This object was especially promoted in France under Colbert, whose regulations to this effect constitute an epoch in the history of dyeing. The gay dye, which only aimed at a transient beauty, was practiced by a particular guild. On the other hand, great pains were taken to define the technical processes which promised durability. And thus, after considering the artificial extraction, the evanescence, and the perishable nature of brilliant appearances of color, we are again returned to the desideratum of permanency. Section 49. Nomenclature. 605. After what has been adduced respecting the origin, the increase, and the affinity of colors, we may be better enabled to judge what nomenclature would be desirable in future, and what might be retained of that hitherto in use. 606. The nomenclature of colors, like all other modes of designation, but especially those employed to distinguish the objects of sense, proceeded in the first instance from particular to general, and from general back again to particular terms. The name of the species became a generic name to which the individual was again referred. 607. This method might have been followed in consequence of the mutability and uncertainty of ancient modes of expression, especially since, in the early ages, more reliance may be supposed to have been placed on the vivid impressions of sense. The qualities of objects were described indistinctly because they were impressed clearly on every imagination. 608. The pure chromatic circle was limited, it is true, but specific as it was, it appears to have been applied to innumerable objects, while it was circumscribed by qualifying characteristics. If we take a glance at the copiousness of the Greek and Roman terms, we shall perceive how mutable the words were, and how easily each was adapted to almost every point in the colorific circle. Note W. 609. In modern ages, terms for many new gradations were introduced in consequence of the various operations of dyeing. Even the colors of fashion and their designations represented an endless series of specific hues. We shall, on occasion, employ the chromatic terminology of modern languages, whence it will appear that the aim has gradually been to introduce more exact definitions, and to individualize and arrest a fixed and specific state by language equally distinct. 610. With regard to the German terminology, it has the advantage of possessing 4 monosyllabic names, no longer to be traced to their origin, viz. Yellow, gelb, blue, red, green. They represent the most general idea of color to the imagination, without reference to any very specific modification. 611. If we were to add 2 other qualifying terms to each of these 4, as thus red-yellow and yellow-red, red-blue and blue-red, yellow-green and green-yellow, blue-green and green-blue, we should express the gradations of the chromatic circle with sufficient distinctness. And if we were to add the designations of light and dark, and again define in some measure the degree of purity or its opposite by the monosyllables black, white, gray, brown, we should have a tolerably sufficient range of expressions to describe the ordinary appearances presented to us, without troubling ourselves whether they were produced dynamically or atomically. 612. The specific and proper terms in use might, however, still be conveniently employed, and we have thus made use of the words orange and violet. We have in like manner employed the word purpur to designate a pure central red, because the secretion of the murex or purpura is to be carried to the highest point of culmination by the action of the sunlight on fine linen saturated with the juice. End of section 31.
Section 32 of Theory of Colours. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Theory of Colours by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Recording by Chris Gray. Part L. Minerals. 613. The colours of minerals are all of a chemical nature, and thus the modes in which they are produced may be explained in a general way by what has been said on the subject of chemical colours. 614. Among the external characteristics of minerals, the description of their colours occupies the first place, and great pains have been taken, in the spirit of modern times, to define and arrest every such appearance exactly. By this means, however, new difficulties, it appears to us, have been created, which occasion no little inconvenience in practice. 615. It is true, this precision, when we reflect how it arose, carries with it its own excuse. The painter has at all times been privileged in the use of colours. The few specific hues, in themselves, admitted of no change, but from these innumerable gradations were artificially produced, which imitated the surface of natural objects. It was, therefore, not to be wondered at that these gradations should also be adopted as criterions, and that the artist should be invited to produce tinted patterns with which the objects of nature might be compared, and according to which they were to receive their designations. 616. But, after all, the terminology of colours which has been introduced in mineralogy is open to many objections. The terms, for instance, have not been borrowed from the mineral kingdom, as was possible enough in most cases, but from all kinds of visible objects. Too many specific terms have been adopted, and in seeking to establish new definitions by combining these, the nomenclators have not reflected that they thus altogether efface the image from the imagination, and the idea from the understanding. Lastly, these individual designations of colours, employed to a certain extent as elementary definitions, are not arranged in the best manner as regards their respective derivation from each other. Hence, the scholar must learn every single designation, and impress an almost lifeless but positive language on his memory. The further consideration of this will be too foreign to our present subject. Footnote 1. These remarks have reference to the German mineralogical terminology, -T. Part L. I. Plants. 617. The colours of organic bodies in general may be considered as a higher kind of chemical operation, for which reason the ancients employed the word concoction to designate the process. All the elementary colours, as well as the combined and secondary hues, appear on the surface of organic productions, while on the other hand, the interior, if not colourless, appears, strictly speaking, negative when brought to the light. As we propose to communicate our views respecting organic nature, to a certain extent, in another place, we only insert here what has been before connected with the doctrine of colours, while it may serve as an introduction to the further consideration of the views alluded to, and first, of plants. 618. Seeds, bulbs, roots, and what is generally shut out from the light, or immediately surrounded by the earth, appear, for the most part, white. 619. Plants reared from seed, in darkness, are white, or approaching to yellow. Light, on the other hand, in acting on their colours, acts at the same time on their form. 620. Plants which grow in darkness make, it is true, long shoots from joint to joint, but the stems between two joints are thus longer than they should be. No side stems are produced, and the metamorphosis of the plant does not take place. 621. Light, on the other hand, places it at once in an active state. The plant appears green, and the course of the metamorphosis proceeds uninterruptedly to the period of reproduction. 622. We know that the leaves of the stem are only preparations and pre-significations of the instruments of florification and fruitification, and accordingly we can already see colours in the leaves of the stem which, as it were, announce the flower from afar, as in the case of the amaranthus. 623. There are white flowers whose petals have wrought or refined themselves to the greatest purity. There are coloured ones, in which the elementary hues may be said to fluctuate to and fro. There are some which, in tending to the higher state, have only partially emancipated themselves from the green of the plant. 624. Flowers of the same genus, and even of the same kind, are found of all colours. Roses, and particularly mallows, for example, vary through a great portion of the calorific circle from white to yellow, then through red-yellow to bright red, and from thence to the darkest hue it can exhibit as it approaches blue. 625. Others already begin from a higher degree in the scale, as, for example, the poppy, which is yellow-red in the first instance, and which afterwards approaches a violet hue. 626. Yet the same colours in species, varieties, and even in families and classes, if not constant, are still predominant, especially the yellow colour. Blue is throughout rarer. 627. A process somewhat similar takes place in the juicy capsule of the fruit, for it increases in colour from the green through the yellowish and yellow up to the highest red, the colour of the rind thus indicating the degree of ripeness. Some are coloured all round, some are only on the sunny side, in which last case the augmentation of the yellow into red, the gradations crowding in and upon each other, may be very well observed. 628. Many fruits, too, are coloured internally. Pure red juices, especially, are common. 629. The colour which is found superficially in the flower and penetratingly in the fruit spreads itself through all the remaining parts, colouring the roots and the juices of the stem, and this with a very rich and powerful hue. 630. So, again, the colour of the wood passes from yellow through the different degrees of red up to pure red and on to brown. Blue woods are unknown to me, and in this degree of organisation the active side exhibits itself powerfully, although both principles appear balanced in the general green of the plant. 631. We have seen above that the germ pushing from the earth is generally white and yellowish, but that by means of the action of light and air it acquires a green colour. The same happens with young leaves of trees, as may be seen, for example, in the birch, the young leaves of which are yellowish, and if boiled yield a beautiful yellow juice. Afterwards they become greener, while the leaves of other trees become gradually blue-green. 632. Thus a yellow ingredient appears to belong more essentially to leaves than a blue one, for this last vanishes in the autumn, and the yellow of the leaf appears changed to a brown colour. Still more remarkable, however, are the particular cases where leaves in autumn again become pure yellow, and others increase to the brightest red. 633. Other plants, again, may, by artificial treatment, be entirely converted to a colouring matter, which is as fine, active, and infinitely divisible as any other. Indigo and madder, with which so much is effected, are examples. Lichens are also used for dyes. 634. To this fact another stands immediately opposed. We can, namely, extract the colouring parts of plants, and, as it were, exhibit it apart, while the organisation does not on this account appear to suffer at all. The colours of flowers may be extracted by spirits of wine, and tinge it, the petals meanwhile becoming white. 635. There are various modes of acting on flowers and their juices by reagents. This has been done by Boyle and in many experiments. Roses are bleached by sulphur, and may be restored to their first state by other acids. Roses are turned green by the smoke of tobacco. End of section 32. Recording by Chris Gray, CG Systems and Gadgets, and Plants for Pussycats.
Section 33 of Theory of Colours. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Gillian Hendry. Theory of Colours by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 33. 52. Worms, insects, fishes. 636. With regard to creatures belonging to the lower degrees of organisation, we may first observe that worms, which live in the earth and remain in darkness and cold moisture, are imperfectly negatively coloured. Worms bred in warm moisture and darkness are colourless. Light seems expressly necessary to the definite exhibition of colour. 637. Creatures which live in water, which, although a very dense medium, suffers sufficient light to pass through it, appear more or less coloured. Zoophytes, which appear to animate the purest calcareous earth, are mostly white, yet we find corals deepened into the most beautiful yellow-red. In other cells of worms this colour increases nearly to bright red. 638. The shells of the crustaceous tribe are beautifully designed and coloured, yet it is to be remarked that neither land snails nor the shells of crustacea of fresh water are adorned with such bright colours as those of the sea. 639. In examining shells, particularly such as are spiral, we find that a series of animal organs, similar to each other, must have moved increasingly forward, and in turning on an axis produced the shell in a series of chambers, divisions, tubes, and prominences, according to a plan for ever growing larger. We remark, however, that a tinging juice must have accompanied the development of these organs, a juice which marked the surface of the shell, probably through the immediate cooperation of the sea water, with coloured lines, points, spots, and shadings. This must have taken place at regular intervals, and thus left the indications of increasing growth lastingly on the exterior. Meanwhile the interior is generally found white or only faintly coloured. 640. That such a juice is to be found in shellfish is besides sufficiently proved by experience, for the creatures furnish it in its liquid and colouring state. The juice of the inkfish is an example, but a much stronger is exhibited in the red juice found in many shellfish, which was so famous in ancient times and has been employed with advantage by the moderns. There is, it appears, in the entrails of many of the crustaceous tribe a certain vessel which is filled with a red juice. This contains a very strong and durable colouring substance, so much so that the entire creature may be crushed and boiled, and yet out of this broth a sufficiently strong tinging liquid may be extracted. But the little vessel filled with colour may be separated from the animal, by which means, of course, a concentrated juice is gained. 641. This juice has the property that when exposed to light and air it appears first yellowish, then greenish. It then passes to blue, then to a violet, gradually growing redder, and lastly, by the action of the sun, and especially if transferred to cambric, it assumes a pure bright red colour. 642. Thus we should here have an augmentation, even to culmination, on the minus side, which we cannot easily meet with in inorganic cases. Indeed, we might almost call this example a passage through the whole scale, and we are persuaded that by due experiments the entire revolution of the circle might really be effected, for there is no doubt that by acids duly employed the pure red may be pushed beyond the culminating point towards scarlet. 643. This juice appears on the one hand to be connected with the phenomena of reproduction, eggs being found, the embryos of future shellfish, which contain a similar colouring principle. On the other hand, in animals ranking higher in the scale of being, the secretion appears to bear some relation to the development of the blood. The blood exhibits similar properties in regard to colour. In its thinnest state it appears yellow, thickened, as it is found in the veins, it appears red, while the arterial blood exhibits a brighter red, probably owing to the oxidation which takes place by means of breathing. The venous blood approaches more to violet, and by this mutability denotes the tendency to that augmentation and progression which are now familiar to us. 644. Before we quit the element whence we derived the foregoing examples, we may add a few observations on fishes, whose scaly surface is coloured either altogether in stripes or in spots, and still oftener exhibits a certain iridescent appearance, indicating the affinity of the scales with the coats of shellfish, mother of pearl, and even the pearl itself. At the same time, it should not be forgotten that warmer climates, the influence of which extends to the watery regions, produce, embellish, and enhance these colours in fishes in a still greater degree. 645. In Otaheite, Forster observed fishes with beautifully iridescent surfaces, and this effect was especially apparent at the moment when the fish died. We may here call to mind the hues of the chameleon and other similar appearances, for when similar facts are presented together, we are better enabled to trace them. 646. Lastly, although not strictly in the same class, the iridescent appearance of certain molluscae may be mentioned, as well as a phosphorescence which in some marine creatures, it is said, becomes iridescent just before it vanishes. 647. We now turn our attention to those creatures which belong to light, air, and dry warmth, and it is here that we first find ourselves in the living region of colours. Here, in exquisitely organised parts, the elementary colours present themselves in their greatest purity and beauty. They indicate, however, that the creatures they adorn are still low in the scale of organisation, precisely because these colours can thus appear, as it were, unwrought. Here, too, heat seems to contribute much to their development. 648. We find insects which may be considered altogether as concentrated colouring matter. Among these, the cochineals especially are celebrated. With regard to these, we observe that their mode of settling on vegetables, and even nestling in them, at the same time produces these excrescences which are so useful as mordants in fixing colours. 649. But the power of colour, accompanied by regular organisation, exhibits itself in the most striking manner in those insects which require a perfect metamorphosis for their development, in scarabaei, and especially in butterflies. 650. These last, which might be called true productions of light and air, often exhibit the most beautiful colours, even in their chrysalis state, indicating the future colours of the butterfly, a consideration which, if pursued further hereafter, must undoubtedly afford a satisfactory insight into many a secret of organised being. 651. If again we examine the wings of the butterfly more accurately, and in its net-like web discover the rudiments of an arm, and observe further the mode in which this, as it were, flattened arm is covered with tender plumage and constituted an organ of flying, we believe we recognise a law according to which the great variety of tints is regulated. This will be a subject for further investigation hereafter. 652. That again heat generally has an influence on the size of the creature, on the accomplishment of the form, and on the greater beauty of the colours, hardly needs to be remarked. 53. Birds. 653. The more we approach the higher organisations, the more it becomes necessary to limit ourselves to a few passing observations, for all the natural conditions of such organised beings are the result of so many premises, that, without having at least hinted at these, our remarks would only appear daring, and at the same time insufficient. 654. We find in plants that the consummate flower and fruit are, as it were, rooted in the stem, and that they are nourished by more perfect juices than the original roots first afforded. We remark too that parasitical plants, which derive their support from organised structures, exhibit themselves especially endowed as to their energies and qualities. We might in some sense compare the feathers of birds with plants of this description. The feathers spring up as a last structural result from the surface of a body which has yet much in reserve for the completion of the external economy, and thus are very richly endowed organs. 655. The quills not only grow proportionally to a considerable size, but are throughout branched, by which means they properly become feathers, and many of these feathered branches are again subdivided, thus again recalling the structure of plants. 656. The feathers are very different in shape and size, but each still remains the same organ, forming and transforming itself according to the constitution of the part of the body from which it springs. 657. With the form, the colour also becomes changed, and a certain law regulates the general order of hues, as well as that particular distribution by which a single feather becomes partly coloured. It is from this that all combination of variegated plumage arises, and whence at last the eyes in the peacock's tail are produced. It is a result similar to that which we have already unfolded in treating of the metamorphosis of plants, and which we shall take an early opportunity to prove. 658. Although time and circumstances compel us here to pass by this organic law, yet we are bound to refer to the chemical operations which commonly exhibit themselves in the tinting of feathers in a mode now sufficiently known to us. 659. Plumage is of all colours, yet on the whole yellow deepening to red is commoner than blue. 660. The operation of light on the feathers and their colours is to be remarked in all cases. Thus, for example, the feathers on the breast of certain parrots are strictly yellow. The scale-like anterior portion, which is acted on by the light, is deepened from yellow to red. The breast of such a bird appears bright red, but if we blow into the feathers, the yellow appears. 661. The exposed portion of the feathers is in all cases very different from that which, in a quiet state, is covered. It is only the exposed portion, for instance in ravens, which exhibits the iridescent appearance. The covered portion does not, from which indication the feathers of the tail, when ruffled together, may be at once placed in the natural order again. End of section 33.
Section 34 of Theory of Colours. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jennifer Painter. Theory of Colours by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 34. Mammalia and Human Beings. Paragraph 662. Here the elementary colours begin to leave us altogether. We are arrived at the highest degree of the scale, and shall not dwell on its characteristics long. Paragraph 663. An animal of this class is distinguished among the examples of organized being. Everything that exhibits itself about him is living. Of the internal structure we do not speak, but confine ourselves briefly to the surface. The hairs are already distinguished from feathers, inasmuch as they belong more to the skin, inasmuch as they are simple, thread-like, not branched. They are, however, like feathers, shorter, longer, softer, and firmer, colourless or coloured, and all this in conformity to laws which might be defined. Paragraph 664. White and black, yellow, yellow-red and brown alternate in various modifications, but they never appear in such a state as to remind us of the elementary hues. On the contrary, they are all broken colours subdued by organic concoction, and thus denote, more or less, the perfection of life in the being they belong to. Paragraph 665. One of the most important considerations connected with morphology, so far as it relates to surfaces, is this, that even in quadrupeds the spots of the skin have a relation with the parts underneath them. Capriciously as nature here appears, on a hasty examination, to operate, she nevertheless consistently observes a secret law. The development and application of this, it is true, are reserved only for accurate and careful investigation and sincere co-operation. Paragraph 666. If in some animals portions appear variegated with positive colours, this of itself shows how far such creatures are removed from a perfect organisation, for, it may be said, the nobler a creature is, the more all the mere material of which he is composed is disguised by being wrought together, the more essentially his surface corresponds with the internal organisation, the less can it exhibit the elementary colours. Where all tends to make up a perfect whole, any detached specific developments cannot take place. Paragraph 667. Of man we have little to say, for he is entirely distinct from the general physiological results of which we now treat. So much in this case is in affinity with the internal structure, that the surface can only be sparingly endowed. Paragraph 668. When we consider that brutes are rather encumbered than advantageously provided with intercutaneous muscles, when we see that much that is superfluous tends to the surface, as, for instance, large ears and tails, as well as hair, manes, tufts, we see that nature, in such cases, has much to give away and to lavish. Paragraph 669. On the contrary, the general surface of the human form is smooth and clean, and thus in the most perfect examples the beautiful forms are apparent. For it may be remarked in passing, that a superfluity of hair on the chest, arms, and lower limbs rather indicates weakness than strength. Poets only have sometimes been induced, probably by the example of the ferine nature, so strong in other respects, to extol similar attributes in their rough heroes. Paragraph 670. But we have here chiefly to speak of colour, and observe that the colour of the human skin, in all its varieties, is never an elementary colour, but presents, by means of organic concoction, a highly complicated result. Footnote. This agrees with the general recommendation so often given by high authorities in art to avoid a tinted look in the colour of flesh. The great example of Rubens, whose practice was sometimes an exception to this, may however show that no rule of art is to be blindly or exclusively adhered to. Reynolds, nevertheless, in the midst of his admiration for this great painter, considered the example dangerous, and more than once expresses himself to this effect, observing on one occasion that Rubens, like Baroccio, is sometimes open to the criticism made on an ancient painter, namely, that his figures look as if they fed on roses. Lodovico Dolce, who is supposed to have given the viva voce precepts of Titian in his dialogue, makes Aretino say, "I would generally banish from my pictures those vermilion cheeks with coral lips, for faces thus treated look like masks." Propertius, reproving his Cynthia for using cosmetics, desires that her complexion might exhibit the simplicity and purity of colour, which is seen in the works of Apelles. Those who have written on the practice of painting have always recommended the use of few colours for flesh. Reynolds and others quote even ancient authorities as recorded by Pliny, and Boschini gives several descriptions of the method of the Venetians, and particularly of Titian, to the same effect. They used, he says, earths more than any other colour, and at the utmost only added a little vermilion, minium, and lake, abhorring as a pestilence biadetti, gialli santi, smaltini, verdi azzurri, giallolini. Elsewhere he says, earth should be used rather than other colours. After repeating the above prohibited list, he adds, I speak of the imitation of flesh, for in other things every colour is good. Again, our great Titian used to say that he who wishes to be a painter should be acquainted with 3 colours, white, black, and red. Assuming this account to be a little exaggerated, it is still to be observed that the monotony to which the use of few colours would seem to tend is prevented by the nature of the Venetian process, which was sufficiently conformable to Goethe's doctrine, the gradations being multiplied, and the effect of the colours heightened by using them as semi-opaque mediums. Immediately after the passage last quoted, we read, He also gave this true precept, that to produce a lively colouring in flesh it is not possible to finish at once. As these particulars may not be known to all, we add some further abridged extracts, explaining the order and methods of these different operations. The Venetian painters, says this writer, after having drawn in their subject, go in the masses with very solid colour, without making use of nature or statues. Their great object in this stage of their work was to distinguish the advancing and retiring portions, that the figures might be relieved by means of chiaroscuro, one of the most important departments of colour and form, and indeed of invention. Having decided on their scheme of effect, when this preparation was dry, they consulted nature and the antique, not servilely, but with the aid of a few lines on paper, quattro segni in carta. They corrected their figures without any other model. Then, returning to their brushes, they began to paint smartly on this preparation, producing the colour of flesh. The passage before quoted follows, stating that they used earths chiefly, that they carefully avoided certain colours, and likewise varnishes and whatever produces a shining surface. When this second painting was dry, they proceeded to scumble over this or that figure with a low tint, to make the one next to it come forward, giving another at the same time additional light, for example, on a head, a hand, or a foot, thus detaching them, so to speak, from the canvas. Tintoret's Prigione di Santa Rocco is here quoted. By thus still multiplying these well understood retouchings where required, on the dry surface, a secco, they reduced the whole to harmony. In this operation they took care not to cover entire figures, but rather went on gemming them, gioli landole, with vigorous touches. In the shadows, too, they infused vigour frequently by glazing with asphaltum, always leaving great masses in middle tint, with many darks, in addition to the partial glazings and few lights. The introduction to the subject of Venetian colouring, in the poem by the same author, is also worth transcribing, but as the style is quaint and very concise, a translation is necessarily a paraphrase. The art of colouring has the imitation of qualities for its object. Not all qualities, but those secondary ones which are appreciable by the sense of sight. The eye especially sees colours. The imitation of nature in painting is therefore justly called colouring, but the painter arrives at his end by indirect means. He gives the varieties of tone in masses, he smartly impinges lights, he clothes his preparation with more delicate local hues, he unites, he glazes. Thus everything depends on the method, on the process. For if we look at colour abstractedly, the most positive may be called the most beautiful. But if we keep the end of imitation in view, this shallow conclusion falls to the ground. The refined Venetian manner is very different from mere direct, sedulous imitation. Every one who has a good eye may arrive at such results, but to attain the manner of Paolo of Bassan, of Palma, Tintoret, or Titian, is a very different undertaking. The effects of semi-transparent mediums in some natural productions seem alluded to in the following passage. Nature sometimes accidentally imitates figures in stones and other substances, and although they are necessarily incomplete in form, yet the principle of effect, or depth, resembles the Venetian practice. In a passage that follows, there appears to be an allusion to the production of the atmospheric colours by semi-transparent mediums. End of footnote. Paragraph 671. That the colour of the skin and hair has relation with the differences of character is beyond question, and we are led to conjecture that the circumstance of one or other organic system predominating produces the varieties we see. A similar hypothesis may be applied to nations, in which case it might perhaps be observed that certain colours correspond with certain conformations, which has always been observed of the Negro physiognomy. Paragraph 672. Lastly, we might here consider the problematical question whether all human forms and hues are not equally beautiful, and whether custom and self-conceit are not the causes why one is preferred to another. We venture, however, after what has been adduced, to assert that the white man, that is, he whose surface varies from white to reddish, yellowish, brownish, in short, whose surface appears most neutral in hue and least inclines to any particular or positive colour, is the most beautiful. On the same principle, a similar point of perfection in human conformation may be defined hereafter, when the question relates to form. We do not imagine that this long disputed question is to be thus once for all settled, for there are persons enough who have reason to leave this significancy of the exterior in doubt. But we thus express a conclusion, derived from observation and reflection, such as might suggest itself to a mind aiming at a satisfactory decision. We subjoin a few observations connected with the elementary chemical doctrine of colours. Footnote. The author's conclusion here is unsatisfactory, for the colour of the black races may be considered at least quite as negative as that of Europeans. It would be safer to say that the white skin is more beautiful than the black, because it is more capable of indications of life and indications of emotion. A degree of light which would fail to exhibit the finer varieties of form on a dark surface would be sufficient to display them on a light one, and the delicate mantlings of colour, whether the result of action or emotion, are more perceptible for the same reason. End of footnote. End of section 34.
Section 35 of Theory of Colours. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Theory of Colours by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Part LV. Physical and chemical effects of the transmission of light through coloured mediums. 673. The physical and chemical effects of colourless light are known, so that it is unnecessary here to describe them at length. Colourless light exhibits itself under various conditions as exciting warmth, as imparting a luminous quality to certain bodies, as promoting oxidation and deoxidation. In the modes and degrees of these effects many varieties take place, but no difference is found indicating a principle of contrast such as we find in the transmission of coloured light. We proceed briefly to advert to this. 674. Let the temperature of a dark room be observed by means of a very sensible air thermometer. If the bulb is then brought to the direct sunlight, as it shines into the room, nothing is more natural than that the fluid should indicate a much higher degree of warmth. If upon this we interpose coloured glasses, it follows again quite naturally that the degree of warmth must be lowered, first, because the operation of the direct light is already somewhat impeded by the glass, and again, more especially, because a coloured glass, as a dark medium, admits less light through it. 675. But here a difference in the excitation of warmth exhibits itself to the attentive observer, according to the colour of the glass. The yellow and the yellow-red glasses produce a higher temperature than the blue and blue-red, the difference being considerable. 676. This experiment may be made with the prismatic spectrum. The temperature of the room being first remarked on the thermometer, the blue coloured light is made to fall on the bulb, when a somewhat higher degree of warmth is exhibited, which still increases as the other colours are gradually brought to act on the mercury. If the experiment is made with the water prism, so that the white light can be retained in the centre, this, refracted indeed, but not yet coloured light, is the warmest, and the other colours stand in relation to each other as before. 677. As we here merely describe, without undertaking to deduce or explain this phenomenon, we only remark in passing that the pure light is by no means abruptly and entirely at an end with the red division in the spectrum, but that a refracted light is still to be observed deviating from its course and, as it were, insinuating itself beyond the prismatic image, so that on closer examination it will hardly be found necessary to take refuge in invisible rays and their refraction. 678. The communication of light by means of coloured mediums exhibits the same difference. The light communicates itself to Bologna phosphorus through blue and violet glasses, but by no means through yellow and yellow-red glasses. It has been even remarked that the phosphory which have been rendered luminous under violet and blue glasses become sooner extinguished when afterwards placed under yellow and yellow-red glasses than those which have been suffered to remain in a dark room without any further influence. 679. These experiments, like the foregoing, may also be made by means of the prismatic spectrum, when the same results take place. 680. To ascertain the effect of coloured light on oxidation and deoxidation, the following means may be employed. Let moist, perfectly white muriate of silver be spread on a strip of paper. Place it in the light, so that it may become to a certain degree grey, and then cut it in 3 portions. Of these, one may be preserved in a book, as a specimen of this state. Let another be placed under a yellow-red, and the third under a blue-red glass. The last will become a darker grey, and exhibit a deoxidation. The other, under the yellow-red glass, will, on the contrary, become a lighter grey, and thus approach nearer to the original state of more perfect oxidation. The change in both may be ascertained by a comparison with the unaltered specimen. 681. An excellent apparatus has been contrived to perform these experiments with the prismatic image. The results are analogous to those already mentioned, and we shall hereafter give the particulars, making use of the labours of an accurate observer, who has been for some time carefully prosecuting these experiments. Translator's footnote, see back. Part LVI. Chemical effect in dioptrical achromatism. 682. We first invite our readers to turn to what has been before observed on this subject, to avoid unnecessary repetition here. 683. We can thus give a glass the property of producing much wider coloured edges without refracting more strongly than before, that is, without displacing the object much more perceptibly. 684. This property is communicated to the glass by means of metallic oxides. Minium, melted and thoroughly united with a pure glass, produces this effect, and thus flint glass is prepared with oxide of lead. Experiments of this kind have been carried farther, and the so-called butter of antimony, which, according to a new preparation, may be exhibited as a pure fluid, has been made use of in hollow lenses and prisms, producing a very strong appearance of colour with a very moderate refraction, and presenting the effect which we have called hyperchromatism in a very vivid manner. 685. In common glass, the alkaline nature obviously preponderates, since it is chiefly composed of sand and alkaline salts. Hence, a series of experiments exhibiting the relation of perfectly alkaline fluids to perfect acids might lead to useful results. 686. For, could the maximum and minimum be found, it would be a question whether a refractive medium could not be discovered, in which the increasing and diminishing appearance of colour, an effect almost independent of refraction, could not be done away with altogether, while the displacement of the object would be unaltered. 687. How desirable, therefore, it would be with regard to this last point, as well as for the elucidation of the whole of this third division of our work, and, indeed, for the elucidation of the doctrine of colours generally, that those who are occupied in chemical researches, with new views ever opening to them, should take this subject in hand, pursuing into more delicate combinations what we have only roughly hinted at, and prosecuting their inquiries with reference to science as a whole. End of section 35. Recording by Chris Gray, CG Systems and Gadgets, and Plants for Pussycats.
Section 36 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Brianna. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake, 1810. General Characteristics 688. We have hitherto, in a manner forcibly, kept phenomena asunder, which partly from their nature, partly in accordance with our mental habits, have, as it were, constantly sought to be reunited. We have exhibited them in three divisions. We have considered colours, first as transient, the result of an action and reaction in the eye itself; next as passing effects of colourless, light-transmitting, transparent and opaque mediums on light, especially on the luminous image. Lastly, we arrived at the point where we could securely pronounce them as permanent and actually inherent in bodies. 689. In following this order, we have as far as possible endeavoured to define, to separate and to class the appearances. But now that we need no longer be apprehensive of mixing and confounding them, we may proceed, first, to state the general nature of these appearances considered abstractedly, as an independent circle of facts, and in the next place, to show how this particular circle is connected with other classes of analogous phenomena in nature. The facility with which colour appears. We have observed that colour, under many conditions, appears very easily. The susceptibility of this eye with regard to light, the constant reaction of the retina against it, produce instantaneously a slight iridescence. Every subdued light may be considered as coloured, nay, we ought to call any light coloured, inasmuch as it is seen. Colourless light, colourless surfaces are in some sort abstract ideas. In actual experience we can hardly be said to be aware of them. 691. If light impinges on a colourless body, is reflected from it, or passes through it, colour immediately appears. But it is necessary here to remember what has been so often urged by us, namely that the leading conditions of refraction, reflection, and so on, are not of themselves sufficient to produce the appearance. Sometimes, it is true, light acts as these merely as light, but oftener as a defined, circumscribed appearance, as a luminous image. The semi-opacity of the medium is often a necessary condition, while half the double shadows are required for many colored appearances. In all cases, however, color appears instantaneously. We find, again, that by means of pressure, breathing heat, by various kinds of motion and alteration on smooth clean surfaces, as well as on colorless fluids, color is immediately produced. 692. The slightest change has only to take place to component parts of bodies, whether by immixture with other particles or to such effects, and color either makes its appearance or becomes changed. The force of color. 693. The physical colors, and especially those of the prism, were formerly called colores infatici, on account of their extraordinary beauty and force. Strictly speaking, however, a high degree of effect may be ascribed to all appearances of color, assuming that they are exhibited under the purest and most perfect conditions. 694. The dark nature of color, its full rich quality, and what produces the grave and at the same time fascinating impression we sometimes experience, and as color is to be considered a condition of light, so it cannot dispense with light as the cooperating cause of its appearance, as its basis or ground, as a power thus displaying and manifesting color. The definite nature of color. 695. The existence and the relatively definite character of color are one and the same thing. Light displays itself in the face of nature, and it were with a general indifference, informing us to surrounding objects, perhaps devoid of interest or importance. But color is at all times specific, characteristic, and significant. 696. Considered in a general point of view, color is determined towards one of the two sides. It thus presents a contrast which we call polarity, and which we may fitly designate by the expressions plus and minus. Plus yellow, minus blue. Plus action, minus negation. Plus light, minus shadow. Plus brightness, minus darkness. Plus force, minus weakness. Plus warmth, minus coldness. Plus proximity, minus distance. Plus repulsion, minus attraction. Plus affinity with acids, minus affinity with alkalis. Combination of the two principles. 697. If these specific, contrasted principles are combined, the respective qualities do not therefore destroy each other, for if in this intermixture the ingredients are so perfectly balanced that neither is to be distinctly recognized, the union again acquires a specific character. It appears as a quality by itself in which we no longer think of a combination. The union we call green. 698. Thus, if two opposite phenomena springing from the same source do not destroy each other when combined, but in their union present a third appreciable and pleasing appearance, this result at once indicates their harmonious relation. The more perfect result yet remains to be adverted to. Augmentation to red, 699. Blue and yellow do not admit of increased intensity without presently exhibiting a new appearance in addition to their own. Each color, in its lightest state, is a dark. If condensed, it must become darker, but this effect no sooner takes place than the hue assumes an appearance which we designated by the word reddish. 700. This appearance still increases, so that when the highest degree of intensity is attained, it predominates over the original hue. A powerful impression of light lifts the sensation of red on the retina. In the prismatic yellow-red which springs directly from the yellow, we hardly recognize the yellow. 701. This deepening takes place again by means of colorless semi-transparent mediums, and here we see the effect in its utmost purity and extent. Transparent fluids, colored with any given hues in a series of glass vessels, exhibit it very strikingly. The augmentation is unremittingly repaid and constant. It is universal and obtains in physiological as well as physical and chemical colors. Junction of two augmented extremes, 702. As the extremes of the simple contrasts produce a beautiful and agreeable appearance by their union, so the deepened extremes on being united will present a still more fascinating color. Indeed, it might naturally be expected that we should here find the acme of the whole phenomenon. Completeness, the result of variety, 703. And such is the fact, for pure red appears, a color to which, from its excellence, we have appropriated the term purple. 704. There are various modes in which pure red may appear. By bringing together the violet edge and the yellow-red border in prismatic experiments, by continued augmentation and chemical operations, and by the organic contrast and physiological effects. 705. As a pigment, it cannot be produced by intermixture or union, but only by arresting the hue in substances chemically acted on, at a high culminating point. Hence, the painter is justified in assuming that there are three primitive colors from which he combines all the others. The natural philosopher, on the other hand, assumes only two elementary colors from which he, in like manner, develops and combines the rest. Completeness, the result of variety in color. 706. The various appearances of color, arrested in their different degrees, and seen in juxtaposition, produce a whole. This totally is harmony to eye. 707. The chromatic circle has been gradually presented to us. The various relations of its progression are apparent to us. Two pure original principles in contrast are the foundation of the whole. An augmentation manifests itself by means of which both approach a third state. Hence, there exists on both sides a lowest and highest, a simplest and most qualified state. Again, two combinations present themselves. First, that of the simple primitive contrasts, then that of the deepened contrasts. Harmony of the complete state, 708. The whole ingredients of the chromatic scale, seen in juxtaposition, produce an harmonious impression on the eye. The difference between the physical contrast and the harmonious opposition in all its extent should not be overlooked. The first resides in the pure restricted original dualism, considered in its antagonizing elements. The other results from the fully developed effects of the complete state. 709. Every single opposition, in order to be harmonious, must comprehend the whole. The physiological experiments are sufficiently convincing on this point. A development of all the possible contrasts of the chromatic scale will be shortly given. Facility with which color may be made to tend either to the plus or minus side. 710. We have already had occasion to take notice of the mutability of color in considering its so-called augmentation and progressive variations round the whole circle. But the hues even pass and repass from one side to the other, rapidly and of necessity. 711. Physiological colors are different in appearance as they happen to fall on a dark or on a light ground. In physical colors, the combination of the objective and subjective experiments is very remarkable. The epoptical colors, it appears, are contrasted according to the light shines through or upon them. To what extent the chemical colors may be changed by fire and alkalis has been sufficiently shown in its proper place. Evanescence of color, 712. All that has been adverted to as subsequent to the rapid excitation and definition of color, in mixture, augmentation, combination, separation, not forgetting the law of compensatory harmony, all takes place with the greatest rapidity and facility, but with equal quickness color again altogether disappears. 713. The physiological appearances are in no wise to be arrested. The physical lasts only as long as the external condition lasts. Even the chemical colors have great mutability. They may be made to pass and repass from one side to the other by means of opposite reagents, and may even be annihilated altogether. Permanence of color. The chemical colors afford evidence of very great duration. Colors fixed in a glass by fusion and by nature in gems defy all time and reaction. 715. The art of dyeing again fixes color very powerfully. The hues of pigments which might otherwise be easily rendered mutable by reagents may be communicated to substances in the greatest permanency by means of mordants. End of section 4. Recording by Brianna.
Section 37 of Theory of Colours. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Theory of Colours by Johann Wolfgang von Goethe, translated by Charles Eastlake. Section 37. Part 5. Relation to other pursuits. Relation to philosophy. 716. The investigator of nature cannot be required to be a philosopher, but it is expected that he should so far have attained the habit of philosophizing as to distinguish himself essentially from the world, in order to associate himself with it again in a higher sense. He should form to himself a method in accordance with observation, but he should take heed not to reduce observation to mere notion, to substitute words for this notion, and to use and deal with these words as if they were things. He should be acquainted with the labours of philosophers in order to follow up the phenomena which have been the subject of his observation into the philosophic region. 717. It cannot be required that the philosopher should be a naturalist, and yet his co-operation in physical researches is as necessary as it is desirable. He needs not an acquaintance with details for this, but only a clear view of those conclusions where insulated facts meet. 718. We have before, number 175, alluded to this important consideration, and repeat it here where it is in its place. The worst that can happen to physical science, as well as to many other kinds of knowledge, is that men should treat a secondary phenomenon as a primordial one, and, since it is impossible to derive the original fact from the secondary state, seek to explain what is in reality the cause by an effect made to usurp its place. Hence arises an endless confusion, a mere verbiage, a constant endeavour to seek and to find subterfuges whenever truth presents itself and threatens to be overpowering. 719. While the observer, the investigator of nature, is thus dissatisfied in finding that the appearances he sees still contradict a received theory, the philosopher can calmly continue to operate in his abstract department on a false result, for no result is so false but that it can be made to appear valid, as form without substance by some means or other. 720. If, on the other hand, the investigator of nature can attain to the knowledge of that which we have called a primordial phenomenon, he is safe, and the philosopher with him. The investigator of nature is safe, since he is persuaded that he has here arrived at the limits of his science, that he finds himself at the height of experimental research, a height whence he can look back upon the details of observation in all its steps, and forwards into, if he cannot enter, the regions of theory. The philosopher is safe, for he receives from the experimentalist an ultimate fact, which in his hands now becomes an elementary one. He now justly pays little attention to appearances which are understood to be secondary, whether he already finds them scientifically arranged, or whether they present themselves to his causal observation scattered and confused. Should he even be inclined to go over this experimental ground himself, and not be averse to examination in detail, he does this conveniently, instead of lingering too long in the consideration of secondary and intermediate circumstances, or hastily passing them over without becoming accurately acquainted with them. 721. To place the doctrine of colours nearer, in this sense, within the philosopher's reach, was the author's wish, and although the execution of his purpose, from various causes, does not correspond with his intention, he will still keep this object in view in an intended recapitulation, as well as in the polemical and historical portions of his work, for he will have to return to the consideration of this point hereafter, on an occasion where it will be necessary to speak with less reserve. Relation to mathematics. 722. It may be expected that the investigator of nature, who proposes to treat the science of natural philosophy in its entire range, should be a mathematician. In the Middle Ages, mathematics was the chief organ by means of which men hoped to master the secrets of nature, and even now geometry in certain departments of physics is justly considered of first importance. The author can boast of no attainments of this kind, and on this account confines himself to departments of science which are independent of geometry, departments which in modern times have been opened up far and wide. 724. It will be universally allowed that mathematics, one of the noblest auxiliaries which can be employed by man, has, in one point of view, been of the greatest use to the physical sciences, but that, by a false application of its methods, it has in many respects been prejudicial to them, is also not to be denied. We find it here and there reluctantly admitted. 725. The theory of colours in particular has suffered much, and its progress has been incalculably retarded by having been mixed up with optics generally, a science which cannot dispense with mathematics, whereas the theory of colours, in strictness, may be investigated quite independently of optics. 726. But besides this, there was an additional evil. A great mathematician was possessed with an entirely false notion on the physical origin of colours, yet, owing to his great authority as a geometer, the mistakes which he committed as an experimentalist long became sanctioned in the eyes of a world ever fettered in prejudices. 727. The author of the present inquiry has endeavoured throughout to keep the theory of colours distinct from the mathematics, although there are evidently certain points where the assistance of geometry would be desirable. Had not the unprejudiced mathematicians with whom he has had, or still has, the good fortune to be acquainted, been prevented by other occupations from making common cause with him, his work would not have wanted some merit in this respect. But this very want may be in the end advantageous, since it may now become the object of the enlightened mathematician to ascertain where the doctrine of colours is in need of his aid, and how he can contribute the means at his command with a view to the complete elucidation of this branch of physics. 728. In general, it were to be wished that the Germans, who render such good service to science, while they adopt all that is good from other nations, could by degrees accustom themselves to work in concert. We live, it must be confessed, in an age the habits of which are directly opposed to such a wish. Every one seeks not only to be original in his views, but to be independent of the labours of others, or at least to persuade himself that he is so, even in the course of his life and occupation. It is very often remarked that men who undoubtedly have accomplished much quote themselves only, their own writings, journals, and compendiums, whereas it would be far more advantageous for the individual and for the world if many were devoted to a common pursuit. The conduct of our neighbours, the French, is, in this respect, worthy of imitation. We have a pleasing instance in Cuvier's preface to his Tableau élémentaire de l'histoire naturelle des animaux. 729. He who has observed science and its progress with an unprejudiced eye might even ask whether it is desirable that so many occupations and aims, though allied to each other, should be united in one person, and whether it would not be more suitable for the limited powers of the human mind to distinguish, for example, the investigator and inventor from him who employs and applies the result of experiment? Astronomers, who devote themselves to the observation of the heavens and the discovery or enumeration of stars, have in modern times formed, to a certain extent, a distinct class from those who calculate the orbits, consider the universe in its connection, and more accurately define its laws. The history of the doctrine of colours will often lead us back to these considerations. Relation to the technical operations of the dyer. 730. If in our labours we have gone out of the province of the mathematician, we have, on the other hand, endeavoured to meet the practical views of the dyer, and although the chapter which treats of colour in a chemical point of view is not the most complete and circumstantial, Yet in that portion, as well as in our general observations respecting colour, the dyer will find his views assisted far more than by the theory hitherto in vogue, which failed to afford him any assistance. 731. It is curious, in this view, to take a glance at the works containing directions on the art of dyeing. As the Catholic, on entering his temple, sprinkles himself with holy water, and after bending the knee, proceeds perhaps to converse with his friends on his affairs, without any special devotion, so all the treatises on dyeing begin with a respectful allusion to the accredited theory, without afterwards exhibiting a single trace of any principle deduced from this theory, or showing that it has thrown light on any part of the art, or that it offers any useful hints in furtherance of practical methods. 732. On the other hand, there are men who, after having become thoroughly and experimentally acquainted with the nature of dyes, have not been able to reconcile their observations with the received theory, who have, in short, discovered its weak points, and sought for a general view more consonant to nature and experience. When we come to the names of Castell and Gulich in our historical review, we shall have occasion to enter into this more fully, and an opportunity will then present itself to show that an assiduous experience in taking advantage of every accident may, in fact, be said almost to exhaust the knowledge of the province to which it is confined. The high and complete result is then submitted to the theorist, who, if he examines facts with accuracy and reasons with candour, will find such materials eminently useful as a basis for his conclusions. Relation to physiology and pathology. 733. If the phenomena adduced in the chapter where colours were considered in a physiological and pathological view are for the most part generally known, still some new views, mixed up with them, will not be unacceptable to the physiologist. We especially hope to have given him cause to be satisfied by classing certain phenomena which stood alone, under analogous facts, and thus, in some measure, to have prepared the way for his further investigations. 734. The appendix on pathological colours, again, is admitted to be scanty and unconnected. We reflect, however, that Germany can boast of men who are not only highly experienced in this department, but are likewise so distinguished for general cultivation, that it can cost them but little to revise this portion, to complete what has been sketched, and at the same time to connect it with the higher facts of organisation. Relation to natural history. 735. If we may at all hope that natural history will gradually be modified by the principle of deducing the ordinary appearances of nature from higher phenomena, the author believes he may have given some hints and introductory views bearing on this object also. As colour, in its infinite variety, exhibits itself on the surface of living beings, it becomes an important part of the outward indications, by means of which we can discover what passes underneath. 736. In one point of view it is certainly not to be too much relied on account of its indefinite and mutable nature. Yet even this mutability, inasmuch as it exhibits itself as a constant quality, again becomes a criterion of mutable vitality, and the author wishes nothing more than that time may be granted him to develop the results of his observations on this subject more fully. Here they would not be in their place. Relation to general physics. 737. The state in which general physics now is, appears again particularly favourable to our labours, for natural philosophy, owing to indefatigable and variously directed research, has generally attained such eminence that it appears not impossible to refer a boundless empiricism to one centre. 738. Without referring to subjects which are too far removed from our own province, we observe that the formulae under which the elementary appearances of nature are expressed altogether tend in this direction, and it is easy to see that through this correspondence of expression a correspondence in meaning will necessarily be soon arrived at. 739. True observers of nature, however they may differ in opinion in other respects, will agree that all which presents itself as appearance, all that we meet with as phenomenon, must either indicate an original division which is capable of union, or an original unity which admits of division, and that the phenomenon will present itself accordingly. To divide the united, to unite the divided, is the life of nature. This is the eternal systole and diastole, the eternal collapsion and expansion, the inspiration and expiration of the world in which we live and move. 740. It is hardly necessary to observe that what we here express as number and restrict to dualism is to be understood in a higher sense. The appearance of a fourth order of facts progressively developing themselves is to be similarly understood, but actual observation should, above all, be the basis of all these expressions. 741. Iron is known to us as a peculiar substance, different from other substances. In its ordinary state we look upon it as a mere material remarkable only on account of its fitness for various uses and applications. How little, however, is necessary to do away with the comparative insignificancy of this substance. A twofold power is called forth, which, while it tends again to a state of union, and, as it were, seeks itself, acquires a kind of magical relation with its like, and propagates this double property, which is in fact but a principle of reunion throughout all bodies of the same kind. We here first observe the mere substance, iron. We see the division that takes place in it, propagate itself and disappear, and again easily become re-excited. This, according to our mode of thinking, is a primordial phenomenon in immanent relation with its idea, and which acknowledges nothing earthly beyond it. 742. Electricity is again peculiarly characterized. As a mere quality we are unacquainted with it. For us it is nothing, a zero, a mere point, which, however, dwells in all apparent existences, and at the same time is the point of origin whence, on the slightest stimulus, a double appearance presents itself, an appearance which only manifests itself to vanish. The conditions under which this manifestation is excited are infinitely varied, according to the nature of particular bodies. From the rudest mechanical friction of very different substances with one another, to the mere contiguity of two entirely similar bodies, the phenomenon is present and stirring, nay, striking and powerful, and so decided and specific, that when we employ the terms or formulae polarity, plus and minus, for north and south, for glass and resin, we do so justifiably and in conformity with nature. 743. This phenomenon, although it especially affects the surface, is yet by no means superficial. It influences the tendency or determination of material qualities, and connects itself in immediate co-operation with the important double phenomenon which takes place so universally in chemistry, oxidation and deoxidation. 744. To introduce and include the appearances of colour in this series, this circle of phenomena was the object of our labours. What we have not succeeded in, others will accomplish. We found a primordial vast contrast between light and darkness, which may be more generally expressed by light and its absence. We looked for the intermediate state and sought by means of it to compose the visible world of light, shade, and colour. In the prosecution of this we employed various terms applicable to the development of the phenomena, terms which we adopted from the theories of magnetism, of electricity, and of chemistry. It was necessary, however, to extend this terminology, since we found ourselves in an abstract region and had to express more complicated relations. 745. If electricity and galvanism, in their general character, are distinguished as superior to the more limited exhibition of magnetic phenomena, it may be said that colour, although coming under similar laws, is still superior, for since it addresses itself to the noble sense of vision, its perfections are more generally displayed. Compare the varied effects which result from the augmentation of yellow and blue to red, from the combination of these two higher extremes to pure red, and the union of the two inferior extremes to green. What a far more varied scheme is apparent here than that in which magnetism and electricity are comprehended. These last phenomena may be said to be inferior again on another account, for though they penetrate and give life to the universe, they cannot address themselves to man in a higher sense in order to his employing them aesthetically. The general, simple physical law must first be elevated and diversified itself in order to be available for elevated uses. 746. If the reader, in this spirit, recalls what has been stated by us throughout, generally and in detail, with regard to colour, he will himself pursue and unfold what has been here only lightly hinted at. He will augur well for science, technical processes, and art, if it should prove possible to rescue the attractive subject of the doctrine of colours from the atomic restriction and isolation in which it has been banished. In order to restore it to the general dynamic flow of life and action which the present age loves to recognise as nature, these considerations will press upon us more strongly when, in the historical portion, we shall have to speak of many an enterprising and intelligent man who failed to possess his contemporaries with his convictions. Relation to the theory of music. 747. Before we proceed to the moral associations of colour and the aesthetic influences arising from them, we have here to say a few words on its relation to melody. That a certain relation exists between the two has been always felt. This is proved by the frequent comparisons we meet with, sometimes as passing allusions, sometimes as circumstantial parallels. The error which writers have fallen into in trying to establish this analogy we would thus define. 748. Colour and sound do not admit of being directly compared together in any way, but both are referable to a higher formula, both are derivable, although each for itself, from this higher law. They are like two rivers which have their source in one and the same mountain, but subsequently pursue their way under totally different conditions, in two totally different regions, so that throughout the whole course of both no two points can be compared. Both are general, elementary effects, acting according to the general law of separation and tendency to union, of undulation and oscillation, yet acting thus in wholly different provinces, in different modes, on different elementary mediums, for different senses. 749. Could some investigator rightly adopt the method in which we have connected the doctrine of colours with natural philosophy generally, and happily supply what has escaped or been missed by us? The theory of sound, we are persuaded, might be perfectly connected with general physics. At present it stands, as it were, isolated within the circle of science. 750. It is true it would be an undertaking of the greatest difficulty to do away with the positive character which we are now accustomed to attribute to music, a character resulting from the achievements of practical skill, from accidental, mathematical, aesthetical influences, and to substitute for all this a merely physical inquiry tending to resolve the science into its first elements. Yet, considering the point at which science and art are now arrived, considering the many excellent preparatory investigations that have been made relative to this subject, we may perhaps still see it accomplished. Concluding observations on terminology. 751. We never sufficiently reflect that a language, strictly speaking, can only be symbolical and figurative, that it can never express things directly, but only, as it were, reflectedly. This is especially the case in speaking of qualities which are only imperfectly presented to observation, which might rather be called powers than objects, and which are ever in movement throughout nature. They are not to be arrested, and yet we find it necessary to describe them. Hence we look for all kinds of formulae in order, figuratively at least, to define them. 752. Metaphysical formulae have breadth as well as depth, but on this very account they require a corresponding import. The danger here is vagueness. Mathematical expressions may in many cases be very conveniently and happily employed, but there is always an inflexibility in them, and we presently feel their inadequacy, for even in elementary cases we are very soon conscious of an incommensurable idea. They are, besides, only intelligible to those who are especially conversant in the sciences to which such formulae are appropriated. The terms of the science of mechanics are more addressed to the ordinary mind, but they are ordinary in other senses, and always have something unpolished. They destroy the inward life to offer from without an insufficient substitute for it. The formulae of the corpuscular theories are nearly allied to the last. Through them the mutable becomes rigid, description and expression uncouth, while again moral terms, which undoubtedly can express nicer relations, have the effect of mere symbols in the end, and are in danger of being lost in a play of wit. 753. If, however, a writer could use all these modes of description and expression with perfect command, and thus give forth the results of his observations on the phenomena of nature in a diversified language, if he could preserve himself from predilections, still embodying a lively meaning in as animated an expression, we might look for much instruction communicated in the most agreeable of forms. 754. Yet how difficult it is to avoid substituting this sign for the thing! How difficult to keep the essential quality still living before us, and not to kill it with the word! With all this, we are exposed in modern times to a still greater danger by adopting expressions and terminologies from all branches of knowledge and science to embody our views of simple nature. Astronomy, cosmology, geology, natural history, nay, religion and mysticism, are called in aid, and how often do we not find a general idea in an elementary state rather hidden and obscured than elucidated and brought nearer to us by the employment of terms, the application of which is strictly specific and secondary. We are quite aware of the necessity which led to the introduction and general adoption of such a language. We also know that it has become in a certain sense indispensable, but it is only a moderate, unpretending recourse to it, with an internal conviction of its fitness, that can recommend it. 755. After all, the most desirable principle would be that writers should borrow the expressions employed to describe the details of a given province of investigation from the province itself, treating the simplest phenomenon as an elementary formula, and deriving and developing the more complicated designations from this. 756. The necessity and suitableness of such a conventional language, where the elementary sign expresses the appearance itself, has been duly appreciated by extending, for instance, the application of the term polarity, which is borrowed from the magnet to electricity, etc. The plus and minus, which may be substituted for this, have found as suitable an application to many phenomena. Even the musician, probably without troubling himself about these other departments, has been naturally led to express the leading difference in the modes of melody by major and minor. 757. For ourselves, we have long wished to introduce the term polarity into the doctrine of colours. With what right and in what sense the present work may show. Perhaps we may hereafter find room to connect the elementary phenomena together, according to our mode, by a similar use of symbolic terms, terms which must at all times convey the directly corresponding idea. We shall thus render more explicit what has been here only alluded to generally, and perhaps too vaguely expressed. End of section 37.
Section 38 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in May 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 38. Part 6. Effect of color with reference to moral associations. 758. Since color occupies so important a place in the series of elementary phenomena, filling as it does the limited circle assigned to it with fullest variety, we shall not be surprised to find that its effects are at all times decided and significant, and that they are immediately associated with the emotions of the mind. We shall not be surprised to find that these appearances presented singly are specific, that in combination they may produce an harmonious, characteristic, often even an inharmonious effect on the eye, by means of which they act on the mind, producing this impression in their most general elementary character, without relation to the nature or form of the object on whose surface they are apparent. Hence, color considered as an element of art may be made subservient to the highest aesthetical ends. 759. People experience a great delight in color, generally. The eye requires it as much as it requires light. We have only to remember the refreshing sensation we experience, if on a cloudy day the sun illumines a single portion of the scene before us, and displays its colors. That healing powers were ascribed to colored gems may have arisen from the experience of this indefinable pleasure. 760. The colors which we see on objects are not qualities entirely strange to the eye. The organ is not thus merely habituated to the impression. No, it is always predisposed to produce color of itself, and experiences a sensation of delight if something analogous to its own nature is offered to it from without, if its susceptibility is distinctly determined towards a given state. 761. From some of our earlier observations we can conclude that general impressions produced by single colors cannot be changed, that they act specifically and must produce definite, specific states in the living organ. 762. They likewise produce a corresponding influence on the mind. Experience teaches us that particular colors excite particular states of feeling. It is related of a witty Frenchman, Il prétendoit que son ton de conversation avec madame ait-toi changé depuis qu'elle avoit changé en cramoisi le meuble de son cabinet, qui ait-toi bleu. 763. In order to experience these influences completely, the eye should be entirely surrounded with one color. We should be in a room of one color, or look through a colored glass. We are then identified with the hue. It attunes the eye and mind in mere unison with itself. 764. The colors on the plus side are yellow, red-yellow, orange, yellow-red, minium, cinnabar. The feelings they excite are quick, lively, aspiring. Yellow. 765. This is the color nearest the light. It appears on the slightest mitigation of light, whether by semi-transparent mediums or faint reflection from white surfaces. In prismatic experiments it extends itself alone and widely in the light space, and while the two poles remain separated from each other, before it mixes with blue to produce green, it is to be seen in its utmost purity and beauty. How the chemical yellow develops itself in and upon the white has been circumstantially described in its proper place. 766. In its highest purity it always carries with it the nature of brightness, and has a serene, gay, softly exciting character. 767. In this state, applied to dress, hangings, carpeting, etc., it is agreeable. Gold in its perfectly unmixed state, especially when the effect of polish is superadded, gives us a new and high idea of this color. In like manner, a strong yellow, as it appears on satin, has a magnificent and noble effect. 768. We find from experience, again, that yellow excites a warm and agreeable impression. Hence, in painting, it belongs to the illumined and emphatic side. 769. This impression of warmth may be experienced in a very lively manner, if we look at a landscape through a yellow glass, particularly on a grey winter's day. The eye is gladdened, the heart expanded and cheered, a glow seems at once to breathe towards us. 770. If, however, this color in its pure and bright state is agreeable and gladdening, and in its utmost power is serene and noble, it is, on the other hand, extremely liable to contamination, and produces a very disagreeable effect if it is sullied, or in some degree tends to the minus side. Thus the color of sulphur, which inclines to green, has a something unpleasant in it. 771. When a yellow color is communicated to dull and coarse surfaces, such as common cloth, felt, or the like, on which it does not appear with full energy, the disagreeable effect alluded to is apparent. By a slight and scarcely perceptible change, the beautiful impression of fire and gold is transformed into one not undeserving the epithet foul, and the color of honor and joy reversed to that of ignominy and aversion. To this impression the yellow hats of bankrupts and the yellow circles on the mantles of Jews may have owed their origin. Red-yellow. 772. As no color can be considered as stationary, so we can very easily augment yellow into reddish by condensing or darkening it. The color increases in energy and appears in red-yellow more powerful and splendid. 773. All that we have said of yellow is applicable here in a higher degree. The red-yellow gives an impression of warmth and gladness, since it represents the hue of the intenser glow of fire, and of the milder radiance of the setting sun. Hence it is agreeable around us, and again, as clothing, in greater or less degrees is cheerful and magnificent. A slight tendency to red immediately gives a new character to yellow, and while the English and Germans content themselves with bright pale yellow colors in leather, the French, as Castel has remarked, prefer a yellow enhanced to red. Indeed, in general, everything in color is agreeable to them which belongs to the active side. Yellow-red. 774. As pure yellow passes very easily to red-yellow, so the deepening of this last to yellow-red is not to be arrested. The agreeable, cheerful sensation which red-yellow excites increases to an intolerably powerful impression in bright yellow-red. 775. The active side is here in its highest energy, and it is not to be wondered at that impetuous, robust, uneducated men should be especially pleased with this color. Among savage nations the inclination for it has been universally remarked, and when children, left to themselves, begin to use tints, they never spare vermilion and minium. 776. In looking steadfastly at a perfectly yellow-red surface, the color seems actually to penetrate the organ. It produces an extreme excitement, and still acts thus when somewhat darkened. A yellow-red cloth disturbs and enrages animals. I have known men of education to whom its effect was intolerable if they chanced to see a person dressed in a scarlet cloak on a grey, cloudy day. 777. The colors on the minus side are blue, red-blue, and blue-red. They produce a restless, susceptible, anxious impression. Blue. 778. As yellow is always accompanied with light, so it may be said that blue still brings a principle of darkness with it. 779. This color has a peculiar and almost indescribable effect on the eye. As a hue it is powerful, but it is on the negative side, and in its highest purity is, as it were, a stimulating negation. Its appearance, then, is a kind of contradiction between excitement and repose. 780. As the upper sky and distant mountains appear blue, so a blue surface seems to retire from us. 781. But as we readily follow an agreeable object that flies from us, so we love to contemplate blue, not because it advances to us, but because it draws us after it. Blue gives us an impression of cold, and thus again reminds us of shade. We have before spoken of its affinity with black. 783. Rooms which are hung with pure blue appear in some degree larger, but at the same time empty and cold. 784. The appearance of objects seen through a blue glass is gloomy and melancholy. 785. When blue partakes in some degree of the plus side, the effect is not disagreeable. Sea green is rather a pleasing color. Red-blue. 786. We found yellow very soon tending to the intense state, and we observed the same progression in blue. 787. Blue deepens very mildly into red, and thus acquires a somewhat active character, although it is on the passive side. Its exciting power is, however, of a very different kind from that of red-yellow. It may be said to disturb rather than enliven. 788. As augmentation itself is not to be arrested, so we feel an inclination to follow the progress of the color, not, however, as in the case of the red-yellow, to see it still increase in the active sense, but to find a point to rest in. 789. In a very attenuated state, this color is known to us under the name of lilac, but even in this degree it has a something lively without gladness. 790. This unquiet feeling increases as the hue progresses, and it may be safely assumed that a carpet of a perfectly pure deep blue-red would be intolerable. On this account, when it is used for dress, ribbons, or other ornaments, it is employed in a very attenuated and light state, and thus displays its character as above defined, in a peculiarly attractive manner. 798. As the higher dignitaries of the Church have appropriated this unquiet color to themselves, we may venture to say that it unceasingly aspires to the Cardinal's red through the restless degrees of a still impatient progression. Red. 792. We are here to forget everything that borders on yellow or blue. We are to imagine an absolutely pure red, like fine carmine suffered to dry on white porcelain. We have called this color purpur by way of distinction, although we are quite aware that the purple of the ancients inclined more to blue. 793. Whoever is acquainted with the prismatic origin of red will not think it paradoxical if we assert that this color partly actu, partly potentia, includes all the other colors. 794. We have remarked a constant progress or augmentation in yellow and blue, and seen what impressions were produced by the various states. Hence it may naturally be inferred that now, in the junction of the deepened extremes, a feeling of satisfaction must succeed, and thus, in physical phenomena, this highest of all appearances of color arises from the junction of two contrasted extremes, which have gradually prepared themselves for a union. 795. As a pigment, on the other hand, it presents itself to us already formed, and is most perfect as a hue in cochineal, a substance which, however, by chemical action may be made to tend to the plus or the minus side, and may be considered to have attained the central point in the best carmine. 796. The effect of this color is as peculiar as its nature. It conveys an impression of gravity and dignity, and at the same time of grace and attractiveness. The first in its dark, deep state, the latter in its light attenuated tint, and thus the dignity of age and the amiableness of youth may adorn itself with degrees of the same hue. 797. History relates many instances of the jealousy of sovereigns with regard to the quality of red. Surrounding accompaniments of this color have always a grave and magnificent effect. 798. The red glass exhibits a bright landscape in so dreadful a hue as to inspire sentiments of awe. 799. Kermes and cochineal, the two materials chiefly employed in dyeing to produce this color, incline more or less to the plus or minus state, and may be made to pass and repass the culminating point by the action of acids and alkalis. It is to be observed that the French arrest their operations on the active side, as is proved by the French scarlet, which inclines to yellow. The Italians, on the other hand, remain on the passive side, for their scarlet has a tinge of blue. 800. By means of a similar alkaline treatment, the so-called crimson is produced, a color which the French must be particularly prejudiced against, since they employ the expressions sot en cramoisi, méchant en cramoisi, to mark the extreme of the silly and the reprehensible. Green. 801. If yellow and blue, which we consider as the most fundamental and simple colors, are united as they first appear, in the state of their action, the color which we will call green is the result. 802. The eye experiences a distinctly grateful impression from this color. If the two elementary colors are mixed in perfect equality, so that neither predominates, the eye and the mind repose on the result of this junction as upon a simple color. The beholder has neither the wish nor the power to imagine a state beyond it. Hence, for rooms to live in constantly, the green color is most generally selected. End of section 38. Section 39 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in April 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 39. Completeness and Harmony. 803. We have hitherto assumed, for the sake of clearer explanation, that the eye can be compelled to assimilate or identify itself with a single color, but this can only be possible for an instant. 804. For when we find ourselves surrounded by a given color which excites its corresponding sensation on the eye, and compels us by its presence to remain in a state identical with it, this state is soon found to be forced, and the organ unwillingly remains in it. 805. When the eye sees a color, it is immediately excited, and it is its nature, spontaneously and of necessity, at once to produce another, which with the original color comprehends the whole chromatic scale. A single color excites, by a specific sensation, the tendency to universality. 806. To experience this completeness, to satisfy itself, the eye seeks for a colorless space next every hue in order to produce the complemental hue upon it. 807. In this resides the fundamental law of all harmony of colors, of which every one may convince himself by making himself accurately acquainted with the experiments which we have described in the chapter on the physiological colors. 808. If, again, the entire scale is presented to the eye externally, the impression is gladdening, since the result of its own operation is presented to it in reality. We turn our attention, therefore, in the first place, to this harmonious juxtaposition. 809. As a very simple means of comprehending the principle of this, the reader has only to imagine a movable diametrical index in the colorific circle. The index, as it revolves round the whole circle, indicates at its two extremes the complemental colors, which, after all, may be reduced to three contrasts. 810. Yellow demands red-blue, blue demands red-yellow, red demands green, and contrariwise. 811. In proportion as one end of the supposed index deviates from the central intensity of the colors, arranged as they are in the natural order, so the opposite end changes its place in the contrasted gradation, and by such a simple contrivance the complemental colors may be indicated at any given point. A chromatic circle might be made for this purpose, not confined, like our own, to the leading colors, but exhibiting them with their transitions in an unbroken series. This would not be without its use, for we are here considering a very important point which deserves all our attention. 812. We before stated that the eye could be in some degree pathologically affected by being long confined to a single color. That, again, definite moral impressions were thus produced, at one time lively and aspiring, at another susceptible and anxious, now exalted to grand associations, now reduced to ordinary ones. We now observe that the demand for completeness, which is inherent in the organ, frees us from this restraint. The eye believes itself by producing the opposite of the single color forced upon it, and thus attains the entire impression which is so satisfactory to it. 813. Simple, therefore, as these strictly harmonious contrasts are, as presented to us in the narrow circle, the hint is important, that nature tends to emancipate the sense from confined impressions by suggesting and producing the whole, and that in this instance we have a natural phenomenon immediately applicable to aesthetic purposes. 814. While, therefore, we may assert that the chromatic scale, as given by us, produces an agreeable impression by its ingredient hues, we may here remark that those have been mistaken who have hitherto adduced the rainbow as an example of the entire scale, for the chief color, pure red, is deficient in it, and cannot be produced, since in this phenomenon, as well as in the ordinary prismatic series, the yellow-red and blue-red cannot attain to a union. 815. Nature perhaps exhibits no general phenomenon where the scale is in complete combination. By artificial experiments such an appearance may be produced in its perfect splendor. The mode, however, in which the entire series is connected in a circle is rendered most intelligible by tints on paper, till after much experience and practice, aided by due susceptibility of the organ, we become penetrated with the idea of this harmony, and feel it present in our minds. 816. Besides these pure, harmonious, self-developed combinations, which always carry the conditions of completeness with them, there are others which may be arbitrarily produced, and which may be most easily described by observing that they are to be found in the colorific circle, not by diameters, but by chords, in such a manner that an intermediate color is passed over. 817. We call these combinations characteristic, because they have all a certain significancy and tend to excite a definite impression, an impression, however, which does not altogether satisfy, inasmuch as every characteristic quality of necessity presents itself only as a part of a whole, with which it has a relation, but into which it cannot be resolved. 818. As we are acquainted with the impressions produced by the colors singly as well as in their harmonious relations, we may at once conclude that the character of the arbitrary combinations will be very different from each other as regards their significancy. We proceed to review them separately. Yellow and blue. 819. This is the simplest of such combinations. It may be said that it contains too little, for since every trace of red is wanting in it, it is defective as compared with the whole scale. In this view it may be called poor, and as the two contrasting elements are in their lowest state, may be said to be ordinary. Yet it is recommended by its proximity to green, in short, by containing the ingredients of an ultimate state. Yellow and red. 820. This is a somewhat preponderating combination, but it has a serene and magnificent effect. The two extremes of the active side are seen together without conveying any idea of progression from one to the other. As the result of their combination in pigments is yellow-red, so they, in some degree, represent this color. Blue and red. 821. The two ends of the passive side, with the excess of the upper end of the active side. The effect of this juxtaposition approaches that of the blue-red produced by their union. Yellow-red and blue-red. 822. These, when placed together, as the deepened extremes of both sides, have something exciting, elevated. They give us a presentiment of red, which in physical experiments is produced by their union. 823. These four combinations have also the common quality of producing the intermediate color of our colorific circle by their union, a union which actually takes place if they are opposed to each other in small quantities and seen from a distance. A surface covered with narrow blue and yellow stripes appears green at a certain distance. 824. If, again, the eye sees blue and yellow next each other, it finds itself in a peculiar disposition to produce green without accomplishing it, while it neither experiences a satisfactory sensation in contemplating the detached colors, nor an impression of completeness in the two. 825. Thus it will be seen that it was not without reason we called these combinations characteristic, the more so since the character of each combination must have a relation to that of the single colors of which it consists. Combinations non-characteristic. 826. We now turn our attention to the last kind of combinations. These are easily found in the circle. They are indicated by shorter chords, for in this case we do not pass over an entire intermediate color, but only the transition from one to the other. 827. These combinations may justly be called non-characteristic, inasmuch as the colors are too nearly alike for their impression to be significant. Yet most of these recommend themselves to a certain degree, since they indicate a progressive state, though its relations can hardly be appreciable. 828. Thus yellow and yellow-red, yellow-red and red, blue and blue-red, blue-red and red, represent the nearest degrees of augmentation and culmination, and in certain relations as to quantity may produce no unpleasant effect. 829. The juxtaposition of yellow and green has always something ordinary, but in a cheerful sense. Blue and green, on the other hand, is ordinary in a repulsive sense. Our good forefathers called these last fool's colors. Relation of the combinations to light and dark. 830. These combinations may be very much varied by making both colors light or both dark, or one light and the other dark, in which modifications, however, all that has been found true in a general sense is applicable to each particular case. With regard to the infinite variety thus produced, we merely observe 831. The colors of the active side placed next to black gain in energy, those of the passive side lose. The active conjoined with white and brightness lose in strength, the passive gain in cheerfulness. Red and green with black appear dark and grave, with white they appear gay. 832. To this we may add that all colors may be more or less broken or neutralized, may to a certain degree be rendered nameless, and thus combined partly together and partly with pure colors, but although the relations may thus be varied to infinity, still all that is applicable with regard to the pure colors will be applicable in these cases. Considerations derived from the evidence of experience and history. 833. The principles of the harmony of colors having been thus far defined, it may not be irrelevant to review what has been adduced in connection with experience and historical examples. 834. The principles in question have been derived from the constitution of our nature and the constant relations which are found to obtain in chromatic phenomena. In experience we find much that is in conformity with these principles, and much that is opposed to them. 835. Men in a state of nature, uncivilized nations, children, have a great fondness for colors in their utmost brightness, and especially for yellow-red. They are also pleased with the motley. By this expression we understand the juxtaposition of vivid colors without an harmonious balance. But if this balance is observed, through instinct or accident, an agreeable effect may be produced. I remember a Hessian officer returned from America, who had painted his face with the positive colors in the manner of the Indians. A kind of completeness or due balance was thus produced, the effect of which was not disagreeable. 836. The inhabitants of the south of Europe make use of very brilliant colors for their dresses. The circumstance of their procuring silk stuffs at a cheap rate is favorable to this propensity. The women especially, with their bright-colored bodices and ribbons, are always in harmony with the scenery, since they cannot possibly surpass the splendor of the sky and landscape. 837. The history of dyeing teaches us that certain technical conveniences and advantages have had great influence on the costume of nations. We find that the Germans wear blue very generally because it is a permanent color in cloth. So in many districts all the country people wear green twill, because that material takes a green dye well. If a traveler were to pay attention to these circumstances, he might collect some amusing and curious facts. 838. Colors, as connected with particular frames of mind, are again a consequence of peculiar character and circumstances. Lively nations, the French for instance, love intense colors, especially on the active side. Sedate nations, like the English and Germans, wear straw-colored or leather-colored yellow accompanied with dark blue. Nations aiming at dignity of appearance, the Spaniards and Italians for instance, suffer the red color of their mantles to incline to the passive side. 839. In dress we associate the character of the color with the character of the person. We may thus observe the relation of colors singly and in combination to the color of the complexion, age, and station. 840. The female sex in youth is attached to rose color and sea green, in age to violet and dark green. The fair-haired prefer violet as opposed to light yellow, the brunettes blue as opposed to yellow-red, and on all good grounds. The Roman emperors were extremely jealous with regard to their purple. The robe of the Chinese emperor is orange embroidered with red, his attendants and the ministers of religion wear citron yellow. 841. People of refinement have a disinclination to colors. This may be owing partly to weakness of sight, partly to the uncertainty of taste, which readily takes refuge in absolute negation. Women now appear almost universally in white, and men in black. 842. An observation, very generally applicable, may not be out of place here, namely that man, desirous as he is of being distinguished, is quite as willing to be lost among his fellows. 843. Black was intended to remind the Venetian noblemen of republican equality. 844. To what degree the cloudy sky of northern climates may have gradually banished color may also admit of explanation. 845. The scale of positive colors is obviously soon exhausted. On the other hand, the neutral, subdued, so-called fashionable colors present infinitely varying degrees and shades, most of which are not unpleasing. 846. It is also to be remarked that ladies, in wearing positive colors, are in danger of making a complexion which may not be very bright still less so, and thus to preserve a due balance with such brilliant accompaniments, they are induced to heighten their complexions artificially. 847. An amusing inquiry might be made which would lead to a critique of uniforms, liveries, cockades, and other distinctions, according to the principles above hinted at. It might be observed, generally, that such dresses and insignia should not be composed of harmonious colors. Uniforms should be characteristic and dignified. Liveries might be ordinary and striking to the eye. Examples both good and bad would not be wanting, since the scale of colors usually employed for such purposes is limited, and its varieties have been often enough tried. End of section 39. Section 40 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in March 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 40. Aesthetic Influence. 848. From the moral associations connected with the appearance of colors, single or combined, their aesthetic influence may now be deduced for the artist. We shall touch the most essential points to be attended to, after first considering the general condition of pictorial representation, light and shade, with which the appearance of color is immediately connected. Chiaroscuro. 849. We apply the term chiaroscuro, hell-dunkel, to the appearance of material objects when the mere effect produced on them by light and shade is considered. 850. In a narrower sense, a mass of shadow lighted by reflexes is often thus designated, but we here use the expression in its first and more general sense. 851. The separation of light and dark from all appearance of color is possible and necessary. The artist will solve the mystery of imitation sooner by first considering light and dark independently of color, and making himself acquainted with it in its whole extent. 852. Chiaroscuro exhibits the substance as substance, inasmuch as light and shade inform us as to degrees of density. 853. We have here to consider the highest light, the middle tint, and the shadow, and in the last the shadow of the object itself, the shadow it casts on other objects, and the illuminated shadow or reflection. 851. The globe is well adapted for the general exemplification of the nature of chiaroscuro, but it is not altogether sufficient. The softened unity of such complete rotundity tends to the vapory, and in order to serve as a principle for effects of art, it should be composed of plane surfaces, so as to define the gradations more. 855. The Italians call this manner il piazzoso. In German it might be called das Flächenhafte. If, therefore, the sphere is a perfect example of natural chiaroscuro, a polygon would exhibit the artist-like treatment in which all kinds of lights, half-lights, shadows, and reflections would be appreciable. 856. The bunch of grapes is recognized as a good example of a picturesque completeness in chiaroscuro, the more so as it is fitted, from its form, to represent a principal group, but it is only available for the master who can see in it what he has the power of producing. 857. In order to make the first idea intelligible to the beginner, for it is difficult to consider it abstractedly even in a polygon, we may take a cube, the three sides of which that are seen represent the light, the middle tint, and the shadow in distinct order. 858. To proceed again to the chiaroscuro of a more complicated figure, we might select the example of an open book, which presents a greater diversity. 859. We find the antique statues of the best time treated very much with reference to these effects. The parts intended to receive the light are wrought with simplicity. The portion originally in shade is, on the other hand, in more distinct surfaces to make them susceptible of a variety of reflections. Here the example of the polygon will be remembered. 860. The pictures of Herculaneum and the Aldobrandini marriage are examples of antique painting in the same style. 861. Modern examples may be found in single figures by Raphael, in entire works by Correggio, and also by the Flemish masters, especially Rubens. Tendency to color. 862. A picture in black and white seldom makes its appearance. Some works of Polidoro are examples of this kind of art. Such works, inasmuch as they can attain form and keeping, are estimable, but they have little attraction for the eye, since their very existence supposes a violent abstraction. 863. If the artist abandons himself to his feeling, color presently announces itself. Black no sooner inclines to blue than the eye demands yellow, which the artist instinctively modifies, and introduces partly pure in the light, partly reddened and subdued as brown in the reflexes, thus enlivening the whole. 864. All kinds of camailleux, or color on similar color, end in the introduction either of a complemental contrast or some variety of hue. Thus, Polidoro in his black and white frescoes sometimes introduced a yellow vase or something of the kind. 865. In general, it may be observed that men have at all times instinctively striven after color in the practice of the art. We need only observe daily how soon amateurs proceed from colorless to colored materials. Paolo Uccello painted colored landscapes to colorless figures. 866. Even the sculpture of the ancients could not be exempt from the influence of this propensity. The Egyptians painted their bas-reliefs. Statues had eyes of colored stones. Porphyry draperies were added to marble heads and extremities, and variegated stalactites were used for the pedestals of busts. The Jesuits did not fail to compose the statue of their Saint Luigi in Rome in this manner, and the most modern sculpture distinguishes the flesh from the drapery by staining the latter. Keeping. 867. If linear perspective displays the gradation of objects in their apparent size as affected by distance, aerial perspective shows us their gradation in greater or less distinctness as affected by the same cause. 868. Although from the nature of the organ of sight we cannot see distant objects so distinctly as nearer ones, yet aerial perspective is grounded strictly on the important fact that all mediums called transparent are in some degree dim. 869. The atmosphere is thus always, more or less, semi-transparent. This quality is remarkable in southern climates, even when the barometer is high, the weather dry, and the sky cloudless, for a very pronounced gradation is observable between objects but little removed from each other. 870. The appearance on a large scale is known to everyone. The painter, however, sees or believes he sees the gradation in the slightest varieties of distance. He exemplifies it practically by making a distinction, for instance, in the features of a face according to their relative position as regards the plane of the picture. The direction of the light is attended to in like manner. This is considered to produce a gradation from side to side, while keeping has reference to depth, to the comparative distinctness of near and distant things. 871. In proceeding to consider this subject, we assume that the painter is generally acquainted with our sketch of the theory of colors, and that he has made himself well acquainted with certain chapters and rubrics which especially concern him. He will thus be enabled to make use of theory as well as practice in recognizing the principles of effect in nature, and in employing the means of art. Color in general nature. 872. The first indication of color announces itself in nature together with the gradations of aerial perspective, for aerial perspective is intimately connected with the doctrine of semi-transparent mediums. We see the sky, distant objects, and even comparatively near shadows, blue. At the same moment, the illuminating and illuminated objects appear yellow, gradually deepening to red. In many cases the physiological suggestion of contrasts comes into the account, and an entirely colorless landscape, by means of these assisting and counteracting tendencies, appears to our eyes completely colored. 873. Local colors are composed of the general elementary colors, but these are determined or specified according to the properties of substances and surfaces on which they appear. This specification is infinite. 874. Thus there is at once a great difference between silk and wool similarly dyed. Every kind of preparation and texture produces corresponding modifications. Roughness, smoothness, polish, all are to be considered. 875. It is therefore one of the pernicious prejudices of art that the skilful painter must never attend to the material of draperies, but always represent, as it were, only abstract folds. Is not all characteristic variety thus done away with, and is the portrait of Leo X less excellent because velvet, satin, and moreen are imitated in their relative effect? 876. In the productions of nature, colors appear more or less modified, specified, even individualized. This may be readily observed in minerals and plants, in the feathers of birds and the skins of beasts. 877. The chief art of the painter is always to imitate the actual appearance of the definite hue, doing away with the recollection of the elementary ingredients of color. This difficulty is in no instance greater than the imitation of the surface of the human figure. 878. The color of flesh, as a whole, belongs to the active side, yet the bluish of the passive side mingles with it. The color is altogether removed from the elementary state and neutralized by organization. 879. To bring the coloring of general nature into harmony with the coloring of a given object will perhaps be more attainable for the judicious artist after the consideration of what has been pointed out in the foregoing theory. For the most fancifully beautiful and varied appearances may still be made true to the principles of nature. Characteristic coloring. 880. The combination of colored objects, as well as the color of their ground, should depend on considerations which the artist pre-establishes for himself. Here a reference to the effect of colors, singly or combined, on the feelings, is especially necessary. On this account the painter should possess himself with the idea of the general dualism, as well as of particular contrasts, not forgetting what has been adverted to with regard to the qualities of colors. 881. The characteristic in color may be comprehended under three leading rubrics, which we here define as the powerful, the soft, and the splendid. 882. The first is produced by the preponderance of the active side, the second by that of the passive side, and the third by completeness, by the exhibition of the whole chromatic scale in due balance. 883. The powerful impression is attained by yellow, yellow-red, and red, which last color is to be arrested on the plus side. But little violet and blue, still less green, are admissible. The soft effect is produced by blue, violet, and red, which in this case is arrested on the minus side, a moderate addition of yellow and yellow-red, but much green may be admitted. 884. If it is proposed to produce both these effects in their full significancy, the complemental colors may be excluded to a minimum, and only so much of them may be suffered to appear as is indispensable to convey an impression of completeness. End of section 40. Section 41 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avayi in March 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 41. Harmonious Coloring. 885. Although the two characteristic divisions as above defined may in some sense be also called harmonious, the harmonious effect, properly so called, only takes place when all the colors are exhibited together in due balance. 886. In this way the splendid as well as the agreeable may be produced. Both of these, however, have of necessity a certain generalized effect, and in this sense may be considered the reverse of the characteristic. 887. This is the reason why the coloring of most modern painters is without character, for, while they follow their general instinctive feeling only, the last result of such a tendency must be mere completeness. This they more or less attain, but thus at the same time neglect the characteristic impression which the subject may demand. 888. But if the principles before alluded to are kept in view, it must be apparent that a distinct style of color may be adopted on safe grounds for every subject. The application requires, it is true, infinite modifications, which can only succeed in the hands of genius. Genuine tone. 889. If the word tone, or rather tune, is to be still borrowed in future from music and applied to coloring, it might be used in a better sense than heretofore. 890. for it would not be unreasonable to compare a painting of powerful effect with a piece of music in a sharp key, a painting of soft effect with a piece of music in a flat key, while other equivalents might be found for the modifications of these two leading modes. False tone. 891. The word tone has been hitherto understood to mean a veil of a particular color spread over the whole picture. It was generally yellow, for the painter instinctively pushed the effect towards the powerful side. 892. If we look at a picture through a yellow glass, it will appear in this tone. It is worthwhile to make this experiment again and again, in order to observe what takes place in such an operation. It is a sort of artificial light, deepening and at the same time darkening the plus side and neutralizing the minus side. 893. This spurious tone is produced instinctively through uncertainty as to the means of attaining a genuine effect, so that instead of completeness, monotony is the result. Weak coloring. 894. It is owing to the same uncertainty that the colors are sometimes so much broken as to have the effect of the grey camailleux, the handling being at the same time as delicate as possible. 895. Their harmonious contrasts are often found to be very happily felt in such pictures, but without spirit, owing to a dread of the motley. The motley. 896. A picture may easily become partly colored or motley when the colors are placed next each other in their full force, as it were only mechanically and according to uncertain impressions. 897. If, on the other hand, weak colors are combined, even although they may be dissonant, the effect, as a matter of course, is not striking. The uncertainty of the artist is communicated to the spectator, who, on his side, can neither praise nor censure. 898. It is also important to observe that the colors may be disposed rightly in themselves, but that a work may still appear motley if they are falsely arranged in relation to light and shade. 899. This may the more easily occur as light and shade are already defined in the drawing, and are, as it were, comprehended in it, while the color still remains open to selection. Dread of theory. 900. A dread of, nay, a decided aversion for all theoretical views respecting color and everything belonging to it has been hitherto found to exist among painters, a prejudice for which, after all, they were not to be blamed, for what has been hitherto called theory was groundless, vacillating, and akin to empiricism. We hope that our labors may tend to diminish this prejudice, and stimulate the artist practically to prove and embody the principles that have been explained. Ultimate aim. 901. But without a comprehensive view of the whole of our theory, the ultimate object will not be attained. Let the artist penetrate himself with all that we have stated. It is only by means of harmonious relations in light and shade, in keeping, in true and characteristic coloring, that a picture can be considered complete, in the sense we have now learned to attach to the term. Grounds. 902. It was the practice of the earlier artists to paint on light grounds. This ground consisted of gypsum and was thickly spread on linen or panel, and then levigated. After the outline was drawn, the subject was washed in with a blackish or brownish color. Pictures prepared in this manner for coloring are still in existence, by Leonardo da Vinci and Fra Bartolomeo. There are also several by Guido. 903. When the artist proceeded to color and had to represent white draperies, he sometimes suffered the ground to remain untouched. Titian did this latterly when he had attained the greatest certainty in practice, and could accomplish much with little labour. The whitish ground was left as a middle tint, the shadows painted in, and the highlights touched on. 904. In the process of colouring, the preparation merely washed, as it were, underneath, was always effective. A drapery, for example, was painted with a transparent colour. The white ground shone through it and gave the colour life, so the parts previously prepared for shadows exhibited the colour subdued, without being mixed or sullied. 905. This method had many advantages, for the painter had a light ground for the light portions of his work, and a dark ground for the shadowed portions. The whole picture was prepared, the artist could work with thin colours in the shadows, and had always an internal light to give value to his tints. In our own time, painting in water-colours depends on the same principles. 906. Indeed, a light ground is now generally employed in oil painting, because middle tints are thus found to be more transparent, and are in some degrees enlivened by a bright ground. The shadows, again, do not so easily become black. 907. It was the practice for a time to paint on dark grounds. Tintoret probably introduced them. Titian's best pictures are not painted on a dark ground. 908. The ground in question was red-brown, and when the subject was drawn upon it, the strongest shadows were laid in, the colours of the lights impasted very thickly in the bright parts, and scumbled towards the shadows, so that the dark ground appeared through the thin colour as a middle tint. Effect was attained in finishing by frequently going over the bright parts and touching on the highlights. 909. If this method especially recommended itself in practice on account of the rapidity it allowed of, yet it had pernicious consequences. The strong ground increased and became darker, and the light colours losing their brightness by degrees, gave the shadowed portions more and more preponderance. The middle tints became darker and darker, and the shadows at last quite obscure. The strongly impasted lights alone remained bright, and we now see only light spots on the painting. The pictures of the Bolognese school and of Caravaggio afford sufficient examples of these results. 910. We may here in conclusion observe that glazing derives its effect from treating the prepared colour underneath as a light ground. By this operation colours may have the effect of being mixed to the eye, may be enhanced, and may acquire what is called tone, but they thus necessarily become darker. Pigments. 911. We receive these from the hands of the chemist and the investigator of nature. Much has been recorded respecting colouring substances, which is familiar to all by means of the press. But such directions require to be revised from time to time. The master meanwhile communicates his experience in these matters to his scholar, and artists generally to each other. Those pigments which according to their nature are the most permanent are naturally much sought after, but the mode of employing them also contributes much to the duration of a picture. The fewest possible colouring materials are to be employed, and the simplest methods of using them cannot be sufficiently recommended. 913. For from the multitude of pigments colouring has suffered much. Every pigment has its peculiar nature as regards its effect on the eye. Besides this, it has its peculiar quality, requiring a corresponding technical method in its application. The former circumstance is a reason why harmony is more difficult of attainment with many materials than with few, the latter why chemical action and reaction may take place among the colouring substances. 914. We may refer, besides, to some false tendencies which the artists suffer themselves to be led away with. Painters are always looking for new coloring substances, and believe, when such a substance is discovered, that they have made an advance in the art. They have a great curiosity to know the practical methods of the old masters, and lose much time in the search. Towards the end of the last century we were thus long tormented with wax painting. Others turn their attention to the discovery of new methods, through which nothing new is accomplished, for, after all, it is the feeling of the artist only that informs every kind of technical process. End of section 41. Section 42 of Theory of Colors. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in March 2017. Theory of Colors by Johann Wolfgang von Goethe. Translated by Charles Eastlake. Section 42. Allegorical, symbolical, mystical application of color. 915. It has been circumstantially shown above that every color produces a distinct impression on the mind, and thus addresses at once the eye and feelings. Hence it follows that color may be employed for certain moral and aesthetic ends. 916. Such an application, coinciding entirely with nature, might be called symbolical, since the color would be employed in conformity with its effect, and would at once express its meaning. If, for example, pure red were assumed to designate majesty, there can be no doubt that this would be admitted to be a just and expressive symbol. All this has been already sufficiently entered into. 917. Another application is nearly allied to this. It might be called the allegorical application. In this there is more of accident and caprice, inasmuch as the meaning of the sign must be first communicated to us before we know what it is to signify. What idea, for instance, is attached to the green color which has been appropriated to hope? 918. That, lastly, color may have a mystical allusion may be readily surmised, for since every diagram in which the variety of colors may be represented points to those primordial relations which belong both to nature and the organ of vision, there can be no doubt that these may be made use of as a language, in cases where it is proposed to express similar primordial relations which do not present themselves to the senses in so powerful and varied a manner. The mathematician extols the value and applicability of the triangle. The triangle is revered by the mystic. Much admits of being expressed in it by diagrams, and, among other things, the law of the phenomena of colors. In this case, indeed, we presently arrive at the ancient mysterious hexagon. 919. When the distinction of yellow and blue is duly comprehended, and especially the augmentation into red, by means of which the opposite qualities tend towards each other and become united in a third, then, certainly, an especially mysterious interpretation will suggest itself, since a spiritual meaning may be connected with these facts. And when we find the two separate principles producing green on the one hand and red in the intenser state, we can hardly refrain from thinking in the first case on the earthly, in the last on the heavenly generation of the Elohim. 920. But we shall do better not to expose ourselves, in conclusion, to the suspicion of enthusiasm, since, if our doctrine of colors finds favor, applications and allusions, allegorical, symbolical, and mystical, will not fail to be made, in conformity with the spirit of the age. Concluding observations. In reviewing this labor, which has occupied me long, and which at last I give but as a sketch, I am reminded of a wish once expressed by a careful writer, who observed that he would gladly see his works printed at once as he conceived them, in order then to go to the task with a fresh eye, since everything defective presents itself to us more obviously in print than even in the cleanest manuscript. This feeling may be imagined to be stronger in my case, since I had not even an opportunity of going through a fair transcript of my work before its publication, these pages having been put together at a time when a quiet, collected state of mind was out of the question. Some of the explanations I was desirous of giving are to be found in the introduction, but in the portion of my work to be devoted to the history of the doctrine of colours, I hope to give a more detailed account of my investigations and the vicissitudes they underwent. One inquiry, however, may not be out of place here, the consideration, namely, of the question, what can a man accomplish who cannot devote his whole life to scientific pursuits? What can he perform as a temporary guest on an estate not his own, for the advantage of the proprietor? When we consider art in its higher character, we might wish that masters only had to do with it, that scholars should be trained by the severest study, that amateurs might feel themselves happy in reverentially approaching its precincts. For a work of art should be the effusion of genius, the artist should evoke its substance and form from his inmost being, treat his materials with sovereign command, and make use of external influences only to accomplish his powers. But if the professor in this case has many reasons for respecting the dilettante, the man of science has every motive to be still more indulgent, since the amateur here is capable of contributing what may be satisfactory and useful. The sciences depend much more on experiment than art, and for mere experiment many a votary is qualified. Scientific results are arrived at by many means, and cannot dispense with many hands, many heads. Science may be communicated, the treasury may be inherited, and what is acquired by one may be appropriated by many. Hence, no one, perhaps, ought to be reluctant to offer his contributions. How much do we not owe to accident, to mere practice, to momentary observation? All who are endowed only with habits of attention, women, children, are capable of communicating striking and true remarks. In science it cannot therefore be required that he who endeavours to furnish something in its aid should devote his whole life to it, should survey and investigate it in all its extent, for this, in most cases, would be a severe condition even for the initiated. But if we look through the history of science in general, especially the history of physics, we shall find that many important acquisitions have been made by single inquirers, in single departments, and very often by unprofessional observers. To whatever direction a man may be determined by inclination or accident, whatever class of phenomena especially strike him, excite his interest, fix his attention, and occupy him, the result will still be for the advantage of science, for every new relation that comes to light, every new mode of investigation, even the imperfect attempt, even error itself, is available. It may stimulate other observers, and is never without its use as influencing future inquiry. With this feeling the author himself may look back without regret on his endeavours. From this consideration he can derive some encouragement for the prosecution of the remainder of his task, and although not satisfied with the result of his efforts, yet reassured by the sincerity of his intentions, he ventures to recommend his past and future labours to the interest of his contemporaries and posterity. Multi per transibunt et augebitur scientia. End of section 42. End of Theory of Colours by Johann Wolfgang von Goethe. Translated by Charles Eastlake.